If you touch a neutron star, you will suddenly disappear before you even feel your finger touch its surface. And not just an ordinary death, your very being, every trillion atom in your body, will be crushed into shapeless matter in less than a millionth of a second. This is the story of the densest object in the universe imaginable, a place where all the laws of physics we know are torn to shreds, a place where even light and time must surrender. Today, we will take you on a journey across space to the final frontier of understanding, to touch what should be the most untouchable thing in the cosmos. Brace yourself, because this is the last second of your humanity and the beginning of becoming part of the universe in a way you've never imagined before. Before we touch it, we need to understand what a neutron star is and why it's one of the most dangerous objects in the universe. Imagine a star 10 to 20 times larger than our Sun. These stars live glorious lives, burning nuclear fuel furiously, shining brightly across the galaxy. But when that fuel runs out, their lives come to an end with the most violent explosion the universe can muster, a supernova, an explosion momentarily brighter than an entire galaxy combined. The force of that explosion is immense, but what's even more terrifying is what's left behind at its core. An unstoppable gravitational force will pull all the massive matter of that star to collapse, collapse, and collapse, compressing everything together until it's only the size of a single city. Yes, you heard that right. A mass greater than the entire Sun, compressed into a sphere just 20 kilometers in diameter. Imagine taking an entire Mount Everest and squeezing it down to the size of a sugar cube. That's the density of a neutron star's matter. Its density? It's the maximum density that normal matter can withstand before becoming a black hole. If you scoop up just 1 teaspoon of it, its weight would be a staggering 1 billion tons, or the equivalent weight of every human on Earth combined in that tiny spoon. It's so heavy it could punch through the Earth's surface all the way to its core. And with this level of density, the gravitational force on the surface of a neutron star is incredibly intense, 200 billion times stronger than Earth's. That means if you accidentally drop a rock on the surface of a neutron star, it would hit at a speed of approximately 7 million kilometers per hour, tens of thousands of times faster than a bullet. Now, imagine you're wearing the strongest spacesuit imaginable, a suit that can withstand radiation and extreme temperatures, and you're floating about 100,000 kilometers away from the neutron star. At this distance, you'll start to see it as a small, bright dot, spinning at an incredible speed. Some neutron stars rotate hundreds of times per second, thousands of times faster than a helicopter blade. We call them pulsars, and they emit beams of X-rays and radio waves like cosmic lighthouses. As you begin to move closer, gravity will greet you brutally. Here, gravity is 200 billion times stronger than Earth's, to the point where the atoms in your body start to feel the difference in gravitational pull. The first thing that happens is your time will begin to distort. According to Einstein's theory of relativity, the more intense the gravity, the slower time moves. For a neutron star, time on its surface will move 30 to 50% slower than on Earth. If your friend were watching you from Earth, they would see you moving slower and slower, like a slow-motion film. Every movement you make would appear sluggish and drawn out, while for you might feel only a few minutes have passed. But on Earth, it could have been hours, or even days. And as you get even closer to the surface, the light reflecting off you will be pulled and distorted, A phenomenon called gravitational lensing will make the images around you curve, so much so that you might even see the back of the neutron star, even while standing in front of it. It's an illusion created by the universe's extreme forces. Furthermore, the surface of a neutron star is covered in superheated plasma, with temperatures reaching millions of degrees Celsius, continuously emitting X-rays. A normal spacesuit cannot protect you from any of this. Within a few hundred kilometers of the surface, your body will face what physicists call spaghettification. It's the stretching out into long, thin strands like spaghetti. But it's not just your body. Everything, from your clothes to the atoms that make up your being, will be stretched. Because a neutron star is small but has immense gravity. The difference in gravitational force between your fingertips and your shoulders will be astronomically different. The pull on your fingers will be millions of times greater than on your shoulders. Your body will be stretched, until it becomes thinner than a strand of hair. But this isn't just muscle stretching, it's stretching at the atomic level. The immense tidal force will tear apart all the chemical bonds in your body. Your bones will shatter, cells will be ripped apart. Even the structure of your DNA will be utterly destroyed. You will become merely a stream of particles stretched out into space. But wait, there's something even more terrifying than gravity. That's the magnetic field. Some neutron stars, known as magnetars, have the strongest magnetic fields in the universe, trillions of times stronger than Earth's magnetic field. So powerful that if you were 1,000 kilometers away from it, its magnetic field would strip all the electrons from the atoms in your body, causing you to instantly disintegrate into plasma. You would become merely a hot gas cloud trapped by the magnetic field. And for rapidly spinning neutron stars like pulsars, the centrifugal force at the surface is also immense. It will try to tear you away from the surface, while gravity tries to pull you down. You will be torn from both directions, an experience no living creature could endure. And then, the moment your fingertip touches the surface of the neutron star, a moment of confronting the universe's harsh reality. Forget about feeling pain, because nerve signals from your finger to your brain travel at about 100 meters per second, but the event that is about to happen is millions of times faster than that, faster than your brain can process. The surface of a neutron star is tens of billions of times stronger than steel. It's a solid crust composed of densely packed nuclei of heavy elements, and it's superheated to 1 million degrees Celsius, hot enough to incinerate everything to ash in an instant. The moment the atoms in your body touch the star, an immense amount of energy will be released. Your body, with a mass of about 60-70 kilograms, will be crushed to the density of a neutron star, which means every atom in you will be compressed until electrons combine with protons to become neutrons. You will become merely a dense cluster of neutrons. This crushing will release energy equivalent to thousands of nuclear explosions simultaneously at a single tiny point. It is the explosion of self, the end of humanity, and the beginning of matter in a new form. Your identity, your memories, the clothes you wear will vanish, becoming merely a thin layer of neutrons, coating the surface of that star. You will be absorbed into the star's structure, becoming completely part of it. You don't die in the normal sense, but you have become part of the densest star in the universe, a massless particle, without feeling, without memory, leaving only increased mass for the neutron star. If you still had consciousness, which of course you wouldn't, you would find that beneath that surface, there's a world stranger than imagination. a world filled with matter in states that don't exist on Earth. Scientists call what's inside nuclear pasta because of the immense pressure. Neutrons are squeezed into various shapes. Some layers look like spaghetti strands, some layers look like lasagna sheets, and some layers look like waffles. It's the most complex structure matter can form under extreme pressure. And if you delve down to the core, you might encounter the most terrifying thing in the universe: strange matter. This is the most perfect, densest, and most dangerous matter, because if it escapes and touches normal matter, it will convert everything it touches into strange matter as well, like a virus that destroys the reality of the universe, turning an entire world into strange matter in an instant. Furthermore, neutron stars can also experience phenomena called starquakes, similar to earthquakes on Earth, but millions of times more powerful. They occur when the solid crust of the neutron star cracks due to torsional forces caused by a sudden decrease in its rotation speed. These tremors release immense energy in the form of gamma rays, which can wipe out life on nearby planets in an instant. And there are some even more terrifying types of neutron stars, black widow pulsars. These are rapidly spinning neutron stars that are devouring matter from their companion stars, like a black widow spider eating its mate after copulation. It's an expression of the universe's endless cruelty. Our journey ends here, where a human disappears in an instant, leaving only the question: how significant are we in this universe, and what is the meaning of our existence? We often think humans are the center of everything. We build cities, we create technology, we have love and dreams, we fight for survival and try to understand this world. But when faced with a neutron star, an object the universe created from the remnants of stars, we become fragile, almost meaningless. Our bodies are just dust blown away by the storm of gravity. All the knowledge we have is just a drop in the ocean of mystery. But that doesn't mean we are worthless. On the contrary, the fact that we can understand the brutality and beauty of a neutron star, even though we are just tiny beings on this blue planet, that is the marvel. The ability to contemplate what we cannot touch is what makes us special. The universe isn't cruel, it doesn't hate us, it's just indifferent. It operates according to its own laws, laws that are both beautiful and terrifying. And sometimes, these laws remind us of our own insignificance and the preciousness of our brief existence. Our duty is not to conquer the gravity of stars or try to dominate the universe, but to use the short time we have to appreciate its grandeur, learn from its mysteries, and live meaningfully before one day we all return to become part of the stars, just as we always have been, merely tiny particles dancing to the rhythm of the cosmos. Imagine this. You're standing in a silent control room. Before you, a vast window reveals millions of stars. Your hand trembles slightly as you rest it on a lever marked C for the speed of light. The moment you push that lever all the way forward, the universe as you know it will collapse in an instant. You might think you're just embarking on an adventure, ready to return and tell exciting stories to your family tomorrow night. But the harsh reality of physics tells us that the second you approach the speed of light, everyone you love, every place you've ever been, and every memory on this earth will have become a distant past, hundreds, even thousands of years away. This is the story of time, not just numbers on a dial, but a river that flows differently for everyone. Today, we'll delve into what would truly happen if humans traveled at the speed of light. What would become of our bodies, our vision, and our time? Get ready, because this is a 30-minute journey that will change your understanding of reality forever. Hello everyone, and welcome to one of the deepest journeys we've ever embarked on. Before we dive into what happens when we travel at the speed of light, we need to understand what light is and why it's so crucial to the universe. In the past, humans viewed light as something magical, appearing instantly when we lit a fire. Philosophers like Aristotle once believed light traveled instantaneously, requiring no time at all. But human curiosity never rests. In 1676, Danish astronomer Ole Rømer observed an anomaly with Jupiter's moons. He noticed that the time it took for a moon to disappear behind Jupiter varied depending on the distance between Earth and Jupiter. That was the first time the world learned that light takes time to travel. So, how fast does light travel? The number scientists currently confirm is 299,792,458 meters per second. To visualize this speed, imagine if there were a road around the world and you drove at the speed of light. You could circle the Earth 7.5 times in just 1 second. This speed is so immense that we almost call it eternal. Yet, for the vastness of the universe, light still seems to crawl. Light from the Sun takes 8 minutes to reach Earth, and light from the nearest star takes 4 years to travel. But what truly makes light the limit of the universe isn't just its speed, it's its constancy. In 1887, two scientists, Michelson and Morley, conducted one of the most famous experiments to find the ether, which was believed to be the medium through which light traveled. The results shocked everyone. No matter which way the Earth moved or from what direction we measured light, its speed always remained the same. It's like if you're running on a train at 10 km/h and the train is moving at 100 km/h, people outside should see you running at 110 km/h, right? But for light, if you turn on a flashlight on a spaceship moving at near light speed, people outside will still see the light traveling at 300,000 kilometers per second, not twice as fast. This paradox baffled the new generation of physicists at the time, until Albert Einstein stepped forward with a world-shattering answer. Einstein said, "If the speed of light must be constant, then what must change is time and space." This was the beginning of the special theory of relativity, which tells us that time is not universal, but rather personal to each individual. And this, my friends, is the first door that leads us to the wonder of time dilation, which we will delve into in the next section. By now, many of you might be wondering, how does the constant speed of light relate to the watch on our wrist? To make it immediately clear, we need to look at what Einstein loved to do most: a thought experiment. Imagine this. We have the strangest clock in the world, a light clock. It consists of two parallel mirrors, one on the floor, the other on the ceiling, exactly 1 meter apart. Inside this clock, a particle of light, or a photon, bounces up and down between the two mirrors. Every time the light hits the bottom mirror, we count it as 1 second. As long as this clock is stationary on Earth, the light simply travels up and down in a straight line for 1 meter. Simple, right? But now, imagine we place this clock on a spaceship hurtling past Earth at a very high speed. For the astronaut on board, he still sees the light traveling up and down in a straight line, the same 1 meter distance. His time, therefore, proceeds normally. But for us, standing on Earth and watching that spaceship zoom by, the sight changes incredibly. Because while the light is traveling from the bottom mirror to the top, the spaceship is also moving forward at high speed. So, from our perspective, the light isn't traveling in a straight line, it's traveling diagonally. Think about it. Which is longer, a straight line or a diagonal line? The answer is definitely the diagonal line. This means that the light in the astronaut's clock has to travel a longer distance from our point of view. And this is where the magic happens. The ironclad rule of the universe states that light cannot accelerate. Its speed must always remain constant. When the distance increases, but the speed remains the same, the only thing the universe can do to make this equation balance is to take more time to complete that 1 second. This is why, while the astronaut feels only 1 second has passed, we on Earth might feel 2 seconds or 10 seconds or even a minute has passed, depending on how fast that ship is moving. This phenomenon is what we call time dilation. To illustrate this chilling difference, let's look at the most famous example, the twin paradox. Suppose there's a pair of twins, Alice and Bob, both 20 years old. Alice decides to travel into space in a ship moving at 99.9% the speed of light while Bob waits on Earth. Alice's round trip takes 1 year according to her ship's clock. When she returns to Earth, she will be 21 years old. But Bob, who waited on Earth, will have aged to 42 years old. Just think about it. Alice is still a young adult who just went on a 1-year trip, but Bob has become a middle-aged man with greying hair. And if Alice were to accelerate even further to 99.9999%, her 1-year trip might lead her to meet Bob's grandchildren or great-grandchildren, because 100 years might have passed on Earth. This is why physicists say that traveling at the speed of light is like time traveling into the future, from which you can never return. Now that we understand time, many might imagine scenes from movies where stars stretch into beautiful white streaks of light. But in reality, if you look out the window of a ship traveling at near light speed, the view you see would look like something out of a nightmare, or perhaps the most insane piece of art ever created. The first phenomenon your warp engine will create is relativistic aberration. Imagine you're running through the rain. Even if the rain is falling straight down as you run faster, the rain seems to come at you from the front, right? Light is the same. When you hurtle forward at near light speed, light from stars to the side, or even stars behind your ship, will be swept to appear directly in front of you. The vast universe around you will begin to curl inward towards a central point in front. Your field of vision will narrow, making it seem like you're looking through a circular tunnel or tunnel vision, which compresses all the light from the entire universe into a single point. But that's not all, because there's also the amazing change in color. This phenomenon is called the Doppler effect in its light version. Light from stars rushing towards you will have its wavelengths compressed, resulting in what's called blue shift. Stars that were once yellow will turn blue, then purple, and eventually become X-rays or gamma rays, invisible to the naked eye. Conversely, stars behind you will have their light waves stretched, resulting in redshift, turning deep red and disappearing into radio waves. The result is that the center of your tunnel will be brightly lit with invisible but high-energy light, while the area around the tunnel will become a dark, empty void. It's a sight that is both beautiful and terrifying at the same time. And we can't forget the secret of Terrell rotation. According to Einstein's theory, objects moving at high speeds appear to contract in the direction of their motion, known as length contraction. But did you know that we wouldn't actually see them flattened? Because light from different parts of an object, such as the front and back, takes different amounts of time to reach our eyes. The visual result is that these objects will appear to rotate or distort from their original shape. Suppose you're flying past a giant cube in space. You wouldn't see it compressed flat, but you'd see it as if it were rotating for you, allowing you to see its back even before you've passed it. The world at light speed is a world where reality is distorted by light, and what the eye sees may not always be what it truly is. By now, many of you might be packing your bags, eager to travel to the future, right? But before we get there, we need to discuss some harsh realities. Why is it that, to this day, the furthest we've sent humans is to the moon? The first problem is mass. According to the world's most famous equation, E=mc², Einstein told us that energy and mass are the same thing. When you try to accelerate a spaceship, the energy you put in doesn't just become speed, it also starts to become the mass of the ship. The faster you go, the heavier your ship becomes, in a physical sense. As you approach the speed of light, the mass of the ship increases exponentially, almost to infinity. And to push an object with infinite mass even faster, you would need an infinite amount of energy. This means that even if you burned all the stars in the universe as fuel, you would never reach 100% the speed of light. Light is like a barrier that the universe has created, preventing anyone from crossing it. The next problem is space dust, which seems harmless. In interstellar space, hydrogen atoms and dust particles are scattered everywhere. At normal speeds, they're just dust hitting a car windshield. But at 99% the speed of light, those hydrogen atoms become cosmic rays with immense energy. They would pierce through the ship, through your body, and destroy your DNA in an instant. Not to mention tiny dust particles the size of a grain of sand. If one of these hits your ship at light speed, the explosion would be as powerful as the atomic bomb at Hiroshima. Traveling at light speed is not a leisurely cruise. It's like constantly running through an invisible nuclear minefield. And finally, there's the issue of communication. Suppose you travel to a star 10 light-years away. The moment you embark, you will be almost permanently cut off from Earth. Because radio waves travel at the speed of light, if you send a message back saying, "I've arrived," that message will take 10 years to reach Earth. And if people on Earth reply, "Congratulations," you'll have to wait another 10 years to receive that message. That's a total of 20 years for just one sentence of conversation. While only a few days might have passed on your ship, you'll feel as if people on Earth are speaking slower and slower until they seem to have stopped forever. So, the speed of light grants us the power to cross time, but at the cost of being completely cut off from everything we love. We've traveled so far from theories that seemed impossible to distorted visions of the universe and the terrifying reality of light speed. Ultimately, the most important question might not be, how can we travel at the speed of light, but rather, what will we do with the time we have? Physics teaches us that time is relative. It can stretch, contract, and change with speed, but that's only the quantity of time in a scientific sense. In terms of human feeling, time isn't measured by the number of seconds that pass, but by the meaning of what we do during that time. Think about it. If a light-speed traveler could live for tens of thousands of years, but had to be alone in the darkness of space, compared to someone who has only 80 years on Earth, but spends every minute loving, learning, and sharing happiness with those around them, who truly has more time? The universe might have created the speed of light as a limit, not to cage us, but to remind us that some of the most precious things don't come from running the fastest. The wonder of life isn't about seeing the future 10,000 years from now, but about seeing the smiles of your loved ones now. It's about feeling the wind, hearing laughter, and feeling your own existence in this very moment. We may never conquer time in a physical sense. We may not be able to stretch it out indefinitely, but we can make every second that passes so valuable that even light itself would have to yield. Thank you all for joining us on this journey. Don't forget to spend the rest of your day on what matters most to you. Have you ever wondered, amidst the millions of stars in the dark night sky, why the universe is so silent? In our Milky Way galaxy alone, there are between 100 billion and 400 billion stars, and in the observable universe, there are trillions more galaxies. Statistically and scientifically, we shouldn't be alone. The universe should be filled with radio signals, spacecraft, or traces of civilizations millions of years more advanced than us. But the most chilling truth might not be that aliens are watching us from the shadows, but that there's no one at all. If today we are the only intelligent life in this boundless void, it's not a cause for celebration. It's not a victory for humanity, but it's the worst news humanity has ever heard. News that could mean the end of everything. In the next 30 minutes, I will take you to explore the surprising silence of the universe, through scientific theories that shake old beliefs and find out why. Loneliness is more terrifying than an extraterrestrial invasion. Get ready, because after this video ends, your perspective on the sky will never be the same again. Imagine a beach stretching as far as the eye can see. Every grain of sand you see is a star in the universe. Astronomers estimate that there are more stars in the observable universe than all the grains of sand on Earth combined. That's a number so vast the human brain can barely comprehend it. In recent decades, advances in astronomy have led to amazing discoveries. We once believed our solar system was special, but the truth is, planets are everywhere. From studies by the Kepler Space Telescope, we found that almost every star in the galaxy has at least one planet orbiting it. And even more exciting is that about 20% of Sun-like stars have Earth-sized planets orbiting in the habitable zone. If we calculate based on these numbers, in our Milky Way galaxy alone, there could be up to 40 billion Earth-like planets. Just stop and think about that number. 40,000 planets. And that's just in one galaxy out of trillions. If we apply the principle of mediocrity, which states that Earth and humans are not special or rare in the universe, we should find that life is common, like finding trees in a forest. And if life is common, advanced civilizations should be abundant. This is the beginning of what's called the Fermi paradox, named after Enrico Fermi, a brilliant physicist, who once asked a short but powerful question. Where is everybody? Let's consider time. Our universe is 13.8 billion years old. Our Earth is 4.5 billion years old. Humans have only developed radio technology for just over 100 years, and only started sending spacecraft beyond Earth a few decades ago. If another civilization arose just 1 million years before us, which in the cosmic scale is a very short time, they should have technology so advanced we can't even imagine it. Even with technologies we know today, such as ion propulsion or solar sails, a civilization could travel from one star to another and colonize the entire Milky Way galaxy in no more than 10 million years. That means the galaxy should have been colonized thousands of times before the first human was even born. But why? When we look up at the sky, do we see only emptiness? The SETI project, or Search for Extraterrestrial Intelligence, has used massive radio telescopes, sweeping for signals from stars for over half a century. We listen to every frequency. We look for laser beams that might be sent from distant civilizations, but the result is the great silence. No radio signals, no traces of massive constructions, not even small probes visiting our solar system. This contradiction forces us to reconsider. Is it possible that our long-held assumptions are wrong? Or is intelligent life not as common in the universe as we thought? In 1961, Dr. Frank Drake proposed an equation to estimate the number of civilizations in our galaxy that we might be able to contact. That is the Drake equation. It consists of factors such as the rate of star formation, the proportion of stars with planets, the number of planets conducive to life, and the probability of life developing intelligence. Initially, scientists were very optimistic. They plugged in numbers and found that there should be thousands or tens of thousands of civilizations in the Milky Way galaxy. But over time, new data has forced us to continuously reduce those numbers. One factor often overlooked is stability. Having a planet in the habitable zone is not enough. It must be a planet with a strong enough magnetic field to protect against cosmic radiation. It must have a large enough moon to stabilize the Earth's axis, to prevent drastic climate changes. And it must have a giant planet like Jupiter, acting as a vacuum cleaner, attracting asteroids and comets to prevent them from frequently hitting Earth. These conditions combined give rise to the concept known as the rare Earth hypothesis, which suggests that, while bacterial life may be common, complex and intelligent life might be an event rarer than winning the lottery 10 times in a row. When attempts to find other civilizations fail, scientists begin to propose a terrifying hypothesis. This is the concept of the Great Filter. This idea suggests that, on the path from inanimate matter to a galaxy-spanning civilization, there must be some obstacle so difficult that almost all civilizations fail and go extinct. This obstacle acts like a filter that prevents anyone from reaching a level where they can contact other civilizations. The most important question for humanity is, have we passed this filter yet? Let's consider the first possibility. The filter is behind us. This is the happiest scenario. It means the greatest obstacle is a past stage that we have already overcome. It could be the origin of life, abiogenesis, which might be so difficult as to be almost impossible. Or it could be the development of eukaryotes, with complex nuclei and internal organelles, which on Earth took over 2 billion years to achieve. If the filter is behind us, humans are the winners in the cosmic game. We are the rarest thing, and we have a bright future ahead of us in colonizing the stars. But let's look at the second, more terrifying possibility. The filter is ahead of us. This is what philosophers like Nick Bostrom fear most. He states that the silence of the universe is ominous. If the filter is ahead of us, it means intelligent life is common. Countless civilizations have arisen in the universe, but all those civilizations disappeared at a certain point. A point where they developed technology to a certain level, and then something happened that caused their extinction. What is that something? Could it be the discovery of nuclear energy, ending in a world-destroying war? Could it be the creation of artificial intelligence, so much smarter than humans that it sees its creators as obstacles and eliminates us? Or could it be a bioweapon created in a lab that escaped? The terrifying thing about the filter ahead is we don't know what it is, and we are confidently heading towards it, like a mouse running into a mousetrap because it sees the cheese. That cheese is technological progress, which we believe will make life better. But in reality, it might be the mechanism that ultimately destroys us. This is why many scientists say not finding aliens at all is good news, because if we found remnants of civilization on Mars, or found bacteria that evolved independently on Jupiter's moon, that would confirm that life arises easily. And if life arises easily, but no one has survived to reach us, that means the great filter is definitely ahead of us, and the chances of humanity surviving it are almost zero. If we have to accept the truth that humanity is the only civilization in this vast universe, the first feeling that arises would be loneliness, a cosmic loneliness that nothing can fill. But within that loneliness, there is a profound meaning hidden. Imagine a universe without intelligent life. There would only be rocks orbiting large fires, swirling gases, light shining into the void. But no one would be able to say how beautiful it is. No one would understand the laws of physics that govern those stars. We humans are the eyes of the universe. We are a part of the universe that has evolved to look back at itself. As Carl Sagan once said, we are star stuff harvesting light. If we are the only civilization, that means all the knowledge, art, culture, and love that exist in the universe are contained only in the brains of living beings on a small planet called Earth. If humanity perishes, the meaning of the universe will also perish. Think about this responsibility. We don't exist only for ourselves, but we exist to be a witness to the grandeur of the universe. If not for us, the universe would just be a machine operating blindly according to its functions. But because of us, the universe has a story, has songs, has paintings, has dreams. The bad news of being alone is not the lack of playmates, but the truth that we are the only backup plan for intelligence. No one will carry on our legacy. No one will preserve our history. If we destroy ourselves, all the efforts of evolution over 4 billion years will become mere dust floating in space, with no one to remember. Finally, no matter what the answer to the Fermi paradox is, whether we are the only civilization that arose amidst incredible coincidence, or just one in a million still lost in the silence, this truth does not diminish the value of your life in the slightest. On the contrary, if this universe truly has no one else, that means you and every human walking on this earth are the most precious thing nature has ever created. You are a miracle that survived the great filter. You are the only light in a dark room as vast as the universe. The philosophy of being alone is not surrendering to despair or fear, but it is an awakening that every second we breathe, every time we share a smile, is an event that may not be found anywhere else in this universe. We should stop competing, stop destroying each other for trivial reasons, and join hands to preserve this lamp of intelligence as best we can. Because we are the universe's only hope. We are the ones who will bring meaning to those dark stars. Live your life to the fullest. Love, create, and learn, so that one day, if we can truly overcome the great filter and travel to the stars, we can tell the empty universe. Thank you for joining us on this journey to the edge of the universe today. The stories of the Fermi paradox and the great filter might sound like bad news, but they are the most powerful reminder of how wonderful our lives are. If you like deep, thought-provoking stories like this, don't forget to like, subscribe, and hit the notification bell so you don't miss our next journey. For you, if one day we find out we are truly alone, how would you feel? Share your thoughts below. I will read every message. If you scream in space, no one can hear you. Imagine this. You're floating adrift in the dark expanse of space, surrounded only by twinkling stars and boundless emptiness. You try to shout, to scream at the top of your lungs, but not even a whisper escapes. There's only silence, consuming everything. This isn't a scene from a sci-fi movie, but a chilling reality of the universe. So why is it? Why can't our voices reach anyone in this vast cosmic ocean? To understand why space is so silent, we need to go back to the basics of sound. Sound is the vibration of particles transmitted through a medium, whether it's air, water, or solids. Think about when you strum a guitar. The strings vibrate, causing the surrounding air to vibrate, and those vibrations travel to our ears, allowing us to hear the music. But in space, especially in the interstellar void, it's a vacuum, a space where there are virtually no particles. Without a medium for vibrations to travel through, sound simply cannot exist. It's like trying to swim in a pool with no water. No matter how much you move your arms and legs, you won't go anywhere. This is the simple, yet powerful scientific reason why the saying, "If you scream in space, no one can hear you," is an undeniable truth. But wait, some of you might argue, why does NASA have sounds from space for us to hear, like the sounds of black holes or various planets? That's because those sounds are not naturally occurring in space, but are what's called sonification, or the conversion of scientific data, such as radio waves, X-rays, or changes in magnetic fields into sound waves that human ears can perceive. For example, the supermassive black hole at the center of the Perseus galaxy cluster. Astronomers found that pressure waves emanating from the black hole create ripples in the surrounding hot gas. These pressure waves can be converted into sound, but they are extremely low frequency, 57 octaves below middle C, which human ears cannot hear. So NASA amplified the frequency of those sounds by 144 quadrillion times, allowing us to hear the awe-inspiring roar of the black hole. Therefore, even though we hear the sound of space, what we're hearing is not sound traveling through a vacuum, but sound recreated from complex data to allow us to experience and understand the universe in another dimension. Now that we understand just how silent space is, the next question is, how would that level of silence affect the human mind? Here on Earth, we rarely experience true silence. Even in the quietest room, there's still the sound of our heartbeat, our blood flowing, or our own breathing. There are special rooms called anechoic chambers, designed to absorb all sound, creating an unprecedented silence. People who have entered these rooms often feel uneasy. Some hear phantom sounds, some feel like they're losing their minds, because our brains are designed to constantly perceive and process sound. When there's no external sound, the brain starts to create its own sounds to fill the void. Now imagine if you were floating adrift in space, many times more silent than an anechoic chamber, devoid of any sound, except for the sounds within your own body. How overwhelming would the feelings of isolation, loneliness, and insignificance be? The silence in space isn't just the absence of sound, but it's the absence of connection, the absence of communication, and the absence of perceiving the existence of others. The silence of space isn't just a scientific phenomenon, but it also inspires many philosophical questions about our existence and our place in the vast universe. The French philosopher Blaise Pascal once said, "The eternal silence of these infinite spaces frightens me." This statement reflects the human feeling of confronting the grandeur and emptiness of the universe. It makes us realize that we are just tiny specks in the immense cosmos, and our existence might hold no meaning at all in the eyes of the universe. But from another perspective, this silence can also be an opportunity for us to look inward, to hear the true sounds of our thoughts and feelings, which are often drowned out by external noise. Space teaches us humility and to accept the unknown. It prompts us to ask questions, to seek meaning, and to create value for our existence. Even if the universe is silent, our inner voice still resonates. Even though space is physically silent, the idea that the universe has music or harmony hidden within it has existed since ancient times. Greek philosophers like Pythagoras believed in the concept called musica universalis, or the music of the spheres. He believed that the movement of stars, the moon, and various planets in the solar system had perfect mathematical proportions and created beautiful music. Even if human ears couldn't hear it, our souls could perceive it. This concept was further developed by astronomers like Johannes Kepler, who believed that the movement of planets corresponded to musical intervals. In the modern era, with sonification technology, we can listen to the universe in a new way. The silence of space is therefore both isolation and connection at the same time. It's isolating because no sound echoes back. No one hears our screams, but at the same time, it connects us to the universe on a deeper level. When we look up at the night sky and see millions of stars, we might feel tiny. But that feeling also makes us realize that we are part of something much larger than ourselves. The silence of space allows us to hear the sound of the universe in a different form, not sound traveling through air, but the sound of physical laws, the sound of emptiness, and the sound of limitless possibilities. It's a silence full of stories, stories of birth, decay, and constant change. Our screams might fade away, but our existence, our thoughts, and our desires remain a part of this grand narrative. In the silence of space, humanity continues to try and send out its voice. We send spacecraft, radio signals, and our hopes out to the stars, even though we know that those sounds might not reach anyone or might take thousands of years to reach their destination. But these actions are not meaningless. They are an expression of humanity's desire to connect, to explore, and to understand. We don't scream for help, but we scream to affirm our existence, to say that we are here, we are looking, and we are learning. Our screams in space might not be heard by anyone, but the echo of our exploration, our learning, and our creation will continue to resonate in the history of humanity and within our own spirits. It's a voice that says, even in the greatest void, we still have meaning. If you scream in space, no one can hear you. This is a harsh truth, but also beautiful at the same time. It teaches us to realize that sometimes the most important sound might not be the loudest sound, but the sound within our own hearts, the sound of curiosity, the sound of fear, the sound of hope, and the sound of love. These sounds don't need a medium to travel, don't need air, don't need waves, because they travel directly through our spirit. So, even if you're floating adrift in the dark expanse of space and screaming at the top of your lungs, unheard by anyone, remember that you are not alone, because your inner voice will always resonate, and that is the most important sound to guide you in this silent universe. This is a journey far beyond anything we've ever dreamed, not just to the moon, not just to Mars, but a journey across the dark expanse of space, to a neighboring galaxy many times larger than our own, the Andromeda Galaxy, 2.5 million light-years from our home. If one day humanity truly reaches it, what will happen? Will our lives change forever? This is a story of possibilities that might just be beyond your imagination. The Andromeda Galaxy, also known as M31, is our closest galactic neighbor, just 2.5 million light-years away from the Milky Way. It's a massive spiral galaxy with a diameter of 220,000 light-years, twice the size of our Milky Way, and contains trillions of stars, compared to the Milky Way's estimated 400 billion. Andromeda is truly a giant of the night sky, but Andromeda's grandeur isn't limited to its size. It also has a long and mysterious history. Scientists believe that Andromeda has already consumed several smaller galaxies, a phenomenon known as galactic cannibalism, which has allowed it to grow immensely. And even more fascinating is Andromeda's core, which doesn't have a single nucleus, but rather a double nucleus, a phenomenon scientists are still studying and trying to understand. The journey to Andromeda isn't just an ordinary space journey, it's a journey through time. With a distance of 2.5 million light-years, even if we travel at the speed of light, the fastest speed in the universe, it would still take 2.5 million years to get there, which is many times longer than a human lifespan. Therefore, if humanity is to truly reach Andromeda, we will need technology far beyond imagination. Perhaps a spacecraft traveling at near light speed, utilizing the principle of time dilation, which would slow down time on board the ship. Or perhaps warp drive technology that distorts space-time to shorten the distance. Or even the transmission of human consciousness, or DNA, to robots or clones, waiting at the destination. The challenges aren't just about speed, but also about surviving in the harsh environment of space. Cosmic radiation, meteoroids, and prolonged weightlessness are all significant obstacles, but with humanity's determination to explore and understand the universe, we might find ways to overcome these. When our spacecraft travels through the long expanse of space and finally reaches the edge of the Andromeda Galaxy, the first sight we behold will surely be an indescribable wonder. Trillions of stars gathered into beautiful spiral arms, vibrant nebulae, and sparkling star clusters. There might even be habitable planets waiting for our discovery. But arriving at Andromeda isn't just a scientific discovery. It's confronting profound questions. Will we find other intelligent life forms? What will their cultures be like? And how will we communicate with them? Or perhaps we won't find anyone at all, and Andromeda will become humanity's new home, where we start a new civilization on a planet no one has ever set foot on before. But before we imagine that far, there's another significant phenomenon that will occur in the distant future. That is the collision of the Milky Way galaxy and the Andromeda Galaxy. Both galaxies are moving towards each other at a speed of approximately 110 kilometers per second and are expected to collide in about 4.5 billion years. Sounds terrifying, doesn't it? But in reality, a galactic collision isn't a direct impact, like two cars crashing. Because most of space is empty, and the distances between stars are vast, the chances of stars directly colliding are very low. But the immense gravitational forces of both galaxies will pull and distort each other's structures, leading to their merger into a large elliptical galaxy, which we might call Milkomeda. And if humanity has already reached Andromeda, what will happen during this collision? Will we become part of the new galaxy, or will we be flung out into the vast emptiness of space? The answer remains a mystery, but one thing is certain. It will be an event that changes the face of the universe, as we know it forever. Whether we truly reach Andromeda or not, or what happens when we get there. Imagining this journey makes us ponder the meaning of exploration. Why do humans want to venture far, to seek the unknown? Perhaps it's not just about discovering new stars or alien life, but about discovering ourselves. The journey to Andromeda reflects the human spirit, the thirst for knowledge, the courage to push boundaries, and the desire to understand our place in the vast universe. It teaches us that we are just a small part in an infinite cosmos. But within this smallness, we possess a great capacity to dream, to create, and to embark on journeys, to seek the truth. And perhaps the answers we seek may not be at the destination of the Andromeda Galaxy, but in the journey itself, a journey that helps us grow, learn, and understand the value of life and the universe we inhabit. The story of the journey to Andromeda remains just an imagination. But who knows? In the distant future, humanity might be able to make this dream a reality. And when that day comes, we will be ready to face what lies ahead. Have you ever imagined traveling to a place in the universe where time moves vastly slower than on Earth? Just 1 hour there could mean decades here. Your loved ones, your family, or even the civilization you know might change beyond recognition. This isn't just science fiction, it's a physical reality known as time dilation, a phenomenon where time doesn't flow in a straight line as we understand it. Today, we'll dive deep into space to discover which places play tricks with time and what it means for our existence. Welcome to our channel. Today, we're unraveling the mystery of time, which many might consider absolute, unchanging. But in reality, time is relative. It can stretch and shrink, depending on certain factors. This concept comes from the great genius, Albert Einstein, with his theory of relativity, which is divided into two main parts. The first is special relativity, which describes the relationship between space and time for objects moving at a constant velocity. The core of this theory is the speed of light in a vacuum is always constant, no matter how fast the observer is moving. The result of this principle is, if you move at a speed close to the speed of light, time for you will slow down compared to someone who is stationary. The second is general relativity, which extends this concept to gravity. Einstein proposed that gravity isn't just an attractive force, but a distortion of space-time caused by massive objects. The more massive an object, the more space-time is distorted, and this distortion causes time to slow down in areas of high gravity. So, the two main factors affecting time dilation are gravity and speed. We can even see its subtle effects in our daily lives. For example, an atomic clock on a mountaintop will run slightly faster than an atomic clock at sea level, because gravity is weaker on the mountaintop. Or even the GPS system we use today. GPS satellites orbit at high speeds, causing time on the satellites to slow down according to special relativity. But at the same time, the satellites are far from Earth, reducing the gravitational pull on them, causing time to speed up according to general relativity. Scientists constantly have to calculate and adjust these times for GPS to work accurately. See, time dilation isn't a distant concept, it's a fascinating part of physical reality. And now, we'll take you to explore places in the universe where this phenomenon fully demonstrates its power. When we talk about places where time slows down to an extreme, nowhere is more prominent than black holes, the most formidable and mysterious objects in the universe. Black holes are formed from the collapse of massive stars, reaching incredibly high densities, creating such intense gravity that not even light can escape. Around black holes, there's a point called the event horizon. This is the point of no return. And what's even more amazing is, for a distant observer, time at the event horizon appears to stand still. Imagine if an astronaut decided to travel close to a black hole and sent a signal back to Earth every second. As he gets closer to the event horizon, the signals sent back to Earth would start to slow down from 1 second to 2 seconds, 10 seconds, until, when he crosses the event horizon, the last signal we receive would seem to be frozen forever. Time for him has stopped from our perspective. The most famous example in popular culture is the movie Interstellar, where astronauts face severe time dilation. On Miller's planet, a planet orbiting the supermassive black hole named Gargantua, just 1 hour they spent exploring that planet was equivalent to 7 years on Earth. That means, if you spent 1 day on Miller's planet, you would return to find that 168 years had passed on Earth. This is the power of gravity distorting time, challenging our familiar concept of time completely. Next to black holes, another type of celestial object with incredibly high density and a significant effect on time is neutron stars. Neutron stars are the remnants of massive stars that collapse after a supernova. They are very small, only about 10-20 kilometers, but have a mass 1.4 times greater than our Sun. Imagine all the matter of the Sun compressed into a city-sized ball. That makes neutron stars the second densest objects in the universe, second only to black holes. The gravity on the surface of a neutron star is immense, 100 billion times stronger than Earth's, or about 10 to the power of 11 times. With such gravity, time on the surface of a neutron star clearly slows down compared to time further away. Although the effects of time dilation are not as extreme as near the event horizon of a black hole, they are significant enough to make a clear difference. If you could stand on the surface of a neutron star, which is practically impossible, you would find that the time on your wrist moves much slower than your friend's watch orbiting far away. Scientists use observations of neutron stars, especially pulsars, which are rapidly rotating neutron stars, emitting radio beams in pulses to study the effects of gravity on time and confirm the accuracy of Einstein's general theory of relativity. Besides black holes and neutron stars, the vicinity of our galaxy's center is also a place where time might slow down. The galactic center is home to a supermassive black hole called Sagittarius A, which has a mass millions of times that of our Sun. Even though we are far from the event horizon of Sagittarius A, the immense gravitational pull of the entire galactic center, including the black hole and countless stars, can still cause a slight time dilation effect. For example, if you were to spend time very close to the galactic center, your clock would run slightly slower than someone on Earth. This effect is very small and not as dramatic as near a black hole, but it is measurable and confirms the principles of general relativity on a galactic scale. So, time dilation is not just a theoretical concept, but a real phenomenon that affects time in various parts of the universe. From the extreme conditions near black holes to the subtle effects in our own galactic neighborhood. What about the early universe? During the Big Bang, the universe was extremely dense and hot, and space-time was highly curved. According to general relativity, in such extreme conditions, time would have moved much slower than it does today. Evidence for this comes from observing distant galaxies, which are essentially looking back in time. Scientists have observed that events in the early universe, such as supernovae, appear to unfold more slowly than similar events in the present universe. This is consistent with the idea that time itself was dilated in the early universe. This phenomenon is known as cosmological time dilation, and it provides crucial evidence for the Big Bang theory and our understanding of the evolution of the universe. Time dilation, a phenomenon that challenges our fundamental understanding of time. It reminds us that time is not a constant, but a dynamic entity, influenced by gravity and speed. From the mind-bending effects near black holes to the subtle shifts in our own solar system. Time dilation is a testament to the universe's incredible complexity and mystery. It makes us question our own perception of time and how we value each moment. If time isn't absolute, then every second we experience becomes even more precious, a unique and unrepeatable moment in the grand tapestry of existence. Albert Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This statement reflects that the time we perceive and experience might not be the whole truth, but merely one perspective, determined by our position and speed in the universe. If time doesn't flow equally for everyone, how should we value the moments we have? The realization that every second we spend is meaningful and irreversible, regardless of whether time moves slowly or quickly in a physical context, should motivate us to live our lives to the fullest. Our existence in the vast universe, where time can be distorted, gives us a different perspective on ourselves. We are just tiny specks in the boundless expanse of time and space. But within this smallness, we have the ability to understand and appreciate the mysteries of the universe. The philosophy of time teaches us humility and to be open to the truth that the world we see might not be the entirety of reality, and there are still many wonders waiting for us to discover and understand. Time dilation is a fascinating phenomenon that reveals the mysteries of the universe and challenges our fundamental understanding of time. From black holes that stop time, to neutron stars that distort space-time, and the early universe where time moved slower. All these remind us that the universe is full of wonders, waiting for us to explore and learn endlessly. Hope you enjoyed this journey through time and space with us today. Don't forget to like, share, and subscribe to our channel so you don't miss out on other interesting science stories. The universe doesn't need us. Have you ever gazed up at the night sky and felt a profound sense of your own insignificance? Those countless twinkling lights weren't made for us. They don't care if we're happy or sad. They don't care if we live or die. This vast, expansive universe has never needed humanity, not even in the slightest. And that is a truth that is both terrifying and liberating all at once. Welcome to a journey exploring a concept that might just shake your beliefs about your own existence. Today, we're going to discuss the idea that the universe doesn't need humanity at all. It might sound distant, or even dismissive of our importance. But in reality, this is a perspective that science and philosophy have highlighted for a very long time, and it might lead to new understandings about life and our meaning in this boundless expanse of space. We often think of Earth and the universe as a backdrop prepared for our appearance, a grand stage awaiting humanity to play its part. But what if, in truth, we are merely a byproduct, a temporary cosmic accident on one blue planet in a small solar system of an ordinary galaxy, which is just one of trillions of galaxies in a universe too vast to imagine? This thought might make us feel worthless, but in another sense, it also grants us immense freedom. From here, we will delve into the scientific evidence that demonstrates the universe's indifference to the existence of life, from the immense scale of space and time to the laws of physics not specifically designed to favor life. And then, we will explore philosophical perspectives that help us discover meaning and the value of being human, even in a universe that never needed us. Prepare yourself for a journey that might change the way you see yourself and the universe forever. To understand why the universe doesn't need us, we must first grasp its scale. Imagine our Milky Way galaxy, with approximately 100 billion to 400 billion stars, and each one might have its own planetary system. Our Earth is just one small planet, orbiting a medium-sized star called the Sun, which is just one of hundreds of billions in this galaxy. But the Milky Way galaxy itself is just one of countless galaxies that we can observe in the universe. Scientists estimate that there are more than 2 trillion galaxies in the observable universe. Just imagine, 2 trillion galaxies, each with hundreds of billions of stars. These numbers are too immense for the human mind to fully comprehend. And in this boundless vastness, the existence of humanity is merely the tiniest speck of dust. It's not just the scale of space, but time is another dimension that further highlights humanity's insignificance. The universe is approximately 13.8 billion years old. Our Earth formed about 4.5 billion years ago. The first single-celled life appeared around 3.8 billion years ago. Multicellular animals began to evolve about 600 million years ago. Dinosaurs ruled the Earth for about 165 million years, and our species, Homo sapiens, only appeared on Earth about 300,000 years ago. If we compress the 13.8 billion year history of the universe into a single calendar year, the Big Bang would occur on January 1st. The Milky Way galaxy would form in May. Our Sun and Earth would come into being in September. Single-celled life would appear in October. Dinosaurs would roam the Earth in mid-December. And humans like us would appear in the last few minutes of December 31st, just seconds before midnight. This shows that our existence is just a brief moment, almost insignificant compared to the universe's long lifespan. The fact that we are just a tiny speck in the vast expanse of space and just a fleeting moment in the long history of the universe doesn't mean our lives are worthless, but it points out that the universe wasn't created for us and has no purpose related to our existence. It is merely a grand backdrop that unfolds according to its own laws, without needing an audience like us. And this is the starting point that will lead us to explore the universe's indifference in other dimensions. Beyond the immense scale of space and time, the laws of physics governing the universe were not designed to specifically favor the emergence or existence of life. On the contrary, these laws are neutral and operate indifferently to the outcomes, whether it's the formation of stars, the explosion of supernovae, or even the formation of complex molecules that lead to life, all follow the fundamental principles of physics without any hidden intentions or purposes. One interesting concept that reinforces this view is the law of entropy, or the second law of thermodynamics, which states that in a closed system, entropy or disorder will always increase. The universe is moving towards a state of maximum entropy, meaning a state where energy is uniformly distributed and there are no complex structures. Ultimately, life, which is a highly ordered system, seems to contradict this trend, but in reality, it might be part of the same process. Physicists like Jeremy England from MIT have proposed an interesting idea that life might simply be a byproduct of the law of entropy itself. He points out that, under certain conditions, groups of atoms will arrange themselves in ways that can absorb and dissipate energy from the environment more effectively. This process leads to the creation of more complex structures and is efficient in increasing the overall entropy of the system. In other words, life might be a type of cosmic heat engine, a mechanism for dissipating energy and increasing overall disorder. It's not a goal, but a tool. This idea doesn't diminish the value of life, but it shows us that our existence is part of a grand natural process, a phenomenon that arises from fundamental laws, not from any divine plan. When we embrace the truth that the universe doesn't need us and isn't concerned with our existence, the question then becomes, what is the meaning of our lives if we are merely insignificant specks in a vast, indifferent cosmos? This question has puzzled thinkers for centuries and led to many different ideas. One of the most prominent ideas is existentialism, which asserts that if there is no predetermined purpose or meaning, then it is our responsibility to create meaning for our own lives. The universe is inherently meaningless. Philosophers like Jean-Paul Sartre and Albert Camus observed that the absurdity of existence doesn't lead to despair, but rather it's a catalyst for us to create value and meaning in our own way. From this perspective, the universe's indifference becomes liberating. It means we have absolute freedom to define our own lives. We are not bound by any external purpose. The meaning of life is not something to be discovered, but something to be created through our actions, our relationships, and our experiences. It's a shift in perspective, from seeking meaning externally to creating meaning internally. Another related idea is cosmic insignificance, which doesn't mean we are worthless, but rather it reminds us of our smallness and the preciousness of what we have. When we understand that, our existence is extraordinary, not because the universe chose us, but because we have the opportunity to experience and create things in this brief time we have. Therefore, instead of feeling disheartened by our smallness, this awareness is an opportunity to create meaning and value for our own lives in the way we want. The universe's indifference makes us free from the pressure to fulfill any cosmic purpose. We are the creators of meaning, and that is our true power. When we look out into the vast universe, with its countless stars and galaxies, a question that scientists and philosophers have long pondered is, why haven't we found any intelligent life yet? This is known as the Fermi paradox. If the universe is so old and has so many planets capable of supporting life and enough time for life to evolve, why haven't we heard from anyone else? One explanation could be the Great Filter, which suggests that there might be some obstacle that prevents intelligent life from developing to a stage where it can communicate with other civilizations. This great filter might be behind us, such as the origin of life, or the evolution of complex cells, which are events that are difficult to occur. Or it might be ahead of us, such as self-destruction through technology, or natural catastrophes that we cannot avoid. The complexity of the universe doesn't necessarily mean anything. It still points out that the existence of humanity might just be a natural occurrence. It doesn't mean that we are the center of everything. It might mean that we are just a coincidence in the vastness of the universe, which operates according to its own laws, without needing any observers or meaning. Conversely, this awareness of our uniqueness can be a powerful motivator. It highlights the value of our existence. If we are the only intelligent life, or one of the few civilizations to overcome the Great Filter, it means our existence is incredibly important, and our lives on this planet are precious. We have a responsibility to care for our Earth and create wonderful things, to make our brief journey meaningful. Our meaning and value are at their highest. Therefore, instead of feeling sad or worthless, we should feel a sense of responsibility and a great opportunity to make our lives full and create infinite meaning. In the brief time we are allowed to be a part of this vast universe, this is a liberating philosophy and opens the door to living a truly free and meaningful life. Throughout our journey today, we have explored concepts that might challenge our beliefs about humanity's place in the universe. We've seen that, from the immense scale of space and time to the indifferent laws of physics and the Great Filter, the universe doesn't need us at all. But this truth doesn't make our lives meaningless. On the contrary, it grants us immense freedom and responsibility. In a universe that doesn't dictate our purpose, we are the creators of meaning. We are the ones who fill it with love, compassion, understanding, and all the emotions that make our existence truly significant. In a universe that doesn't define anything for us, we are the creators of meaning, and that is our true power. Our cosmic insignificance doesn't diminish us, but rather elevates us to the status of meaning makers in a world without inherent meaning. So, live your life mindfully, meaningfully, and bravely, because in this boundless universe, your existence is a true miracle. Not because the universe needs you, but because you choose to be the light in the darkness, the voice in the silence, and the meaning in a meaningless universe. When the last star fades, a journey into the great void. Imagine the darkest night you've ever experienced, not the darkness from storm clouds or the gloom deep within a cave, but a darkness devoid of starlight, devoid of the moon, and even our own sun. A darkness that envelops the entire universe. When the very last star has faded, what would become of us, of everything we've ever known, and of the meaning of our existence? This is the story of a long journey that will take us to the end of all things, and perhaps bring answers to life's greatest questions. Welcome to an astonishing and perhaps slightly unsettling journey. Today, we will explore the distant future of the universe, to a time when the very last star that once twinkled brightly in the sky has finally burned out. This isn't a story of an impending apocalypse, but look millions upon millions of years ahead, to the eternal end of everything we see and touch. Understanding the universe's ultimate demise not only reveals the grandeur of science, but also reflects profound philosophies about life, death, and the meaning of our existence in this vast expanse of space. Before we can imagine the fading of the last star, we must first understand how stars are born, exist, and die. Stars are like colossal living beings in the universe, each with its own life cycle. They are born from immense clouds of dust and gas that collapse under gravity until nuclear fusion ignites in their core, releasing tremendous energy in the form of light and heat. This is when stars shine brightest, much like our own sun today. But this nuclear fuel is finite. As the hydrogen in their cores begins to deplete, stars enter the final stages of their lives. Their fate depends on their initial mass. Stars with low to medium mass, like our sun, will swell into red giants before shedding their outer layers, leaving behind a dense hot core known as a white dwarf. White dwarfs will slowly cool down and fade into darkness over trillions of years. For more massive stars, their end is far more dramatic. They explode as supernovae, leaving behind incredibly dense neutron stars. Or if massive enough, they collapse into black holes, objects with such immense gravity that not even light can escape. As time passes, hundreds of trillions of years, most stars in the universe will have completed their life cycles. The sky we once saw, filled with twinkling stars, will become a vast, empty darkness, with only the remnants of stellar civilizations remaining, such as white dwarfs, neutron stars, and black holes, drifting in the cold, dark void. During this era, the formation of new stars will cease entirely, as there won't be enough gas and dust to coalesce anymore. The universe will enter an epoch known as the degenerate era, a time when energy slowly dissipates and heat spreads uniformly until there are no more temperature differences, which is a crucial condition for chemical reactions and the existence of life. But even in the degenerate era, there is still a faint, final hope: the black dwarf. A black dwarf is the remnant of a white dwarf that has cooled down completely, emitting no more light or heat. They are theoretical objects, because the universe isn't old enough for any black dwarfs to have formed yet. But in the distant future, all white dwarfs will eventually become black dwarfs, drifting in the darkness, a lifeless graveyard of stars. However, the story of black dwarfs might not always end in silence. Professor Matt Kaplan, a physicist from Illinois State University, has proposed a fascinating theory that some black dwarfs with sufficient mass might still explode as supernovae, even without nuclear fusion. According to Kaplan's theory, after an incredibly long time, proton decay in black dwarfs will slowly occur, and iron will accumulate in their cores. When the iron mass reaches a critical point, the black dwarf will rapidly collapse and explode as a black dwarf supernova. This would be the final explosion and the greatest last light in the universe, before everything plunges into eternal darkness. These explosions will occur in a future beyond imagination, perhaps around 10 or 100 years from now, which is millions of trillions of times longer than the current age of the universe. It will be an extremely rare event and a grand finale to the stellar age. Once the last black dwarf supernova has exploded, the universe will enter a state known as heat death. This is the most widely accepted theory about the end of the universe, based on the second law of thermodynamics, which states that entropy, or disorder, of a system always increases. In a state of heat death, the universe will continue to expand until energy and matter are spread out as thinly as possible. Temperatures will drop to near absolute zero, No energy sources will remain, no chemical reactions, no life, no light, and no heat. There will only be a cold, empty void filled with scattered particles, and black holes slowly evaporating through Hawking radiation until eventually even black holes will dissipate, leaving behind perfect emptiness. Imagining the grand end of the universe can evoke a variety of feelings. Some might feel nihilism, believing that everything is meaningless. If everything must eventually end in emptiness, then what is the meaning of our existence, our efforts, our love, our dreams? But on the other hand, some might find a deeper meaning in the realization that our existence is but a brief moment in the long history of the universe. It can be a driving force to live life to the fullest, to create good things, and to leave a legacy, not to fight against the inevitable void, but to celebrate our existence in this incredibly special time. Ultimately, when the last star fades and the universe enters eternal darkness, we may not be there to witness it. But the story of this journey teaches us that, even in the great void, there is still beauty, mystery, and hidden meaning. Scientific knowledge helps us understand how the universe works and how it will end. But philosophy helps us understand how we should live in the time we are given. Perhaps the end of the universe is not a sad story, but a testament to the grandeur of beginnings and the meaning of existence that we create for ourselves. In the brief time, we have the opportunity to be a part of this vast universe. If I were to ask you, what is the most terrifying thing in the entire universe? Most people would probably say black holes, those massive objects that swallow everything in their path, where even light itself can't escape. But in reality, some scientists believe there's something far more frightening out there, because it doesn't just destroy planets, it could erase the entire universe from existence. Black holes aren't as dangerous as you might think. Many imagine them as the ultimate cosmic predators, ready to suck up everything like a giant vacuum cleaner. But that's not entirely true. Think about it this way. If our sun were to suddenly become a black hole with the exact same mass, Earth would still orbit it in the same path. We wouldn't be sucked in instantly like you see in the movies. Sure, black holes are terrifying. Their gravity is so intense that nothing escapes once it crosses the event horizon. But they're still just objects in space, following the laws of physics. They aren't a threat to the entire universe, unlike what some other theories suggest. So, what could possibly be scarier than a black hole? The first contender, false vacuum decay. Imagine our universe is like a ball resting on a small hilltop, rather than sitting securely at the bottom of a valley. This is the concept of a false vacuum, a state where our universe might not be in its most stable energy level. Physicists believe our universe was created in a state called the Higgs vacuum. This energy state of the Higgs field is what gives particles their mass. But if a lower, more stable energy state actually exists, it means the vacuum we live in right now is just a false vacuum. It's unstable. So, what happens if that state changes? It would be like that ball finally rolling down the hill into a deeper, more stable valley. This transition would start at a single point in space and create a new vacuum bubble. This bubble would expand in every direction at nearly the speed of light. And here's the terrifying part. Inside this bubble, every law of physics we know would be completely rewritten. Atoms, matter, planets, stars, and even life itself could not exist as they do now. They would instantly disintegrate, turning into pure energy or shifting into forms we can't even imagine. the most chilling thing about false vacuum decay? If it happens, we'd never see it coming. It would reach us at the speed of light, and everything would end before we could even realize what was happening. It's a silent catastrophe that erases everything from existence, with no warning, no fight, and no escape. The second contender, the Big Rip. If false vacuum decay is a sudden silent end, the Big Rip is a slow, inevitable tearing apart of everything we know. This theory involves dark energy, the mysterious force believed to be causing our universe to expand. And what's truly scary is that this expansion is actually accelerating. Some scientists believe this dark energy might keep getting stronger until it eventually overcomes gravity and every other force holding the universe together. The timeline of the Big Rip is haunting. At first, the push from dark energy would drive galaxies away from each other so fast that every galaxy would end up completely isolated, unable to see any others. Then, the tearing force would grow even stronger. Our solar system would be ripped apart. Planets would be pulled away from the sun, drifting off into the vast darkness of space. Our Earth would be torn to shreds. Mountains would crumble, oceans would evaporate, and the very surface of the planet would be destroyed. Finally, the force would become so intense that it would pull atoms themselves apart. Every chemical bond would break. All matter would become nothing more than solitary particles, floating aimlessly. Even space-time itself would be torn open. No distance, no time, nothing left but a void that has been shredded to pieces. The Big Rip is a brutal finale where everything, no matter how big or small, is destroyed by an unstoppable force, leaving not even a trace of existence behind. The third contender, heat death. If false vacuum decay is a sudden blast and the Big Rip is a violent tearing, heat death is a different kind of horror. It's a nightmare of silence and an endless empty void. Heat death, or the Big Freeze, is based on the second law of thermodynamics, which states that entropy or disorder in a closed system will always increase until it reaches a maximum. Picture our universe as a room filled with energy. In the beginning, this energy is spread unevenly. You have blazing hot stars, active galaxies, and energy flowing everywhere. But over time, this energy will spread out evenly across the entire universe. The differences in temperature and energy density will slowly fade away until everything is the same. In the heat death scenario, there's no big explosion, no spectacular disaster. It's a horror that creeps in slowly and inevitably. Every star will eventually go dark as it runs out of nuclear fuel. White dwarfs, neutron stars, and black holes will be the last things remaining, before they too slowly fade away through Hawking radiation over spans of time longer than we can imagine. No energy will be left to power anything. No chemical reactions, no light, no complex gravity, no life. Nothing can ever happen again. The universe will become a place where nothing changes, nothing moves, and nothing matters. It's a bleak ending where our universe becomes a vast graveyard, without life, without hope, and without purpose. Perhaps the most terrifying thing in the universe isn't actually an object. We've talked about black holes, false vacuum decay, the Big Rip, and heat death. All cosmic phenomena that are terrifying in their own way. Black holes are things we can see and study. As powerful as they are, they're part of the laws of physics we've come to understand. But the real terror might not be any single object or event. It's the fate of the entire universe. A fate that leads to the end of everything we've ever known. No matter how much we advance in science or technology, we might never be able to stop or change these outcomes. We are just tiny beings on a tiny planet in a vast universe, heading toward an end we cannot control. The true horror lies in our inability to even comprehend, let alone resist, the massive forces of the universe as it follows its path. Maybe the most terrifying thing in the universe isn't something that's hunting us down. It's not a black hole swallowing everything or a rogue star on a collision course. It's the reality that one day, everything we've ever known, every memory, every love, every dream, every civilization, every star, and every galaxy might be gone forever, and the universe will just keep going, as if we never even existed. Void, silence, and darkness will take the place of everything. That is the true terror. The terror of being forgotten, of being erased from existence with no one to remember and no one to know we were ever here. And that is the most terrifying thing in the vast universe we call home. Have you ever wondered if the universe we live in might not be all there is? What if everything we've ever believed about the origin of the cosmos is just one piece of a much grander story? And what if the death of one star is the birth of an entirely new universe? Prepare to have your perspective shifted with the idea that inside a black hole could be another universe. Welcome to our channel, where we dive deep into the mysteries of space and explore concepts that challenge our understanding of the cosmos. Today, we're going to talk about one of the most fascinating enigmas in the universe, the black hole, a powerful and mysterious cosmic object from which not even light can escape. But what if we told you that black holes aren't just the end of everything? What if they're a gateway to infinite possibilities? The idea that inside a black hole could be another universe is no longer just a science fiction tale. It's a serious topic being debated by theoretical physicists worldwide. Today, we'll take you on a journey to explore this incredible theory, from the basic concepts of black holes to complex quantum physics theories and the philosophy that might change your view on our very existence. Are you ready to open your mind and step into a world beyond imagination? If you are, let's go. Before we dive into the concept of a universe within a black hole, let's first understand why black holes have always been such a challenging mystery for scientists. According to Einstein's theory of general relativity, when a massive amount of matter collapses under its own gravity, it forms a black hole, with a central point called a singularity. At this point, density and gravity become infinitely high, which current physics cannot explain. It's the point where the laws of physics we know break down, and that's a big problem. But then, some physicists proposed a fascinating solution. That is the Einstein-Cartan theory. This theory doesn't just consider the curvature of spacetime, but also another property called torsion, or the twisting of spacetime. Imagine that. Spacetime doesn't just curve like a stretched fabric, but it can also twist. And this torsion plays a crucial role when matter reaches extreme density, such as inside a black hole. Instead of collapsing into an infinite singularity, the torsion of spacetime creates an immense repulsive force, causing the matter to bounce out, also known as the bounce. And from this bounce, a new universe might be born, which could be our own universe. This concept was proposed by physicists like Nikodem Poplawski, who believes that every black hole in a parent universe could be a gateway to a baby universe. So, instead of a dark end, black holes become cosmic nurseries, continuously creating new universes without end. Amazing, isn't it? If our universe originated from within a black hole, the question then is, what would life be like inside that black hole? According to Poplawski's concept, our universe would continue to expand, just as we observe today. But the key difference is, this expansion doesn't come from a big bang that started from nothingness, but rather from the bounce of matter that collapsed into the parent black hole. So, we might not feel any difference in our daily lives, but on a cosmic scale, it's a huge paradigm shift. What evidence do we have to support this incredible idea? One piece of evidence physicists are looking for is cosmic rotation. If our universe originated from a rotating black hole, also known as a Kerr black hole, we might detect traces of this rotation in the form of certain asymmetries in the cosmic microwave background, or CMB, which is the earliest light remaining from the birth of the universe. Furthermore, the Einstein-Cartan theory can also help solve some problems that general relativity cannot, such as the problems of dark matter and dark energy. By suggesting that the property of torsion might play a role in creating additional gravity or affecting the expansion of the universe, which scientists are currently studying and trying to find evidence for. Another interesting concept is cosmological natural selection by Lee Smolin. He proposes that our universe might be part of a cosmic evolutionary process, where universes that create the most black holes will have the greatest chance of creating descendant universes, similar to natural selection in living organisms. This concept suggests that our universe might be tuned to be suitable for creating black holes and could lead to the emergence of complex life like us. It's a new perspective on the universe, where everything is interconnected and has a deeper purpose than we ever imagined. If our universe originated from a black hole in another universe, that means there's a parent universe above us, and that parent universe might also have originated from a black hole in an even larger universe. This concept leads us to imagine the structure of the cosmos as a fractal, meaning it has repeating patterns at every level. No matter how closely we look or how far out we look, we will find similar structures. Universe within universe, black hole within black hole. It's the concept of cosmic recursion, which tells us that we are part of an endless cycle. The death of a star in one universe is the rebirth of another. And we, who are watching this, could also be a product of this grand process. Throughout our journey today, we've explored concepts that challenge conventional beliefs about black holes and the origin of the universe. From the singularity that was once a mystery to the concept of torsion in the Einstein-Cartan theory, which suggests that a black hole might not be an end, but a beginning. And if this concept is true, it will completely change our perspective on our existence. The philosophy hidden within this concept is, emptiness is not an end, but a beginning. Death is not annihilation, but a transfer of energy. We are not destroyed, but we are the product of transferred energy. And our universe is just one part of a larger structure that constantly cycles, changes, and creates new things. It makes us realize that our lives and the universe we inhabit have a profound meaning and are inextricably linked. Perhaps the answer to life's biggest questions may not be found by looking outside the universe, but by looking into the black hole within ourselves. Can black holes devour each other? A cosmic mystery that shakes space-time. Imagine the boundless void of space. Out there, something is hidden, something so immensely powerful that not even light can escape it. It's a black hole. But what if two black holes orbit each other, performing a cosmic dance of death in the dark expanse of space? And eventually, can they truly devour each other? The whispers from the depths of space, which scientists call gravitational waves, have already confirmed this incredible dance. And today, we'll unravel the mystery of what happens when these cosmic giants decide to merge and what it means for our understanding of the universe. Welcome to a profound journey into the heart of one of the most astonishing phenomena in the universe: black holes. For many, black holes might just be strange objects that swallow everything, but in reality, they are the greatest natural physics laboratories where the laws of gravity are pushed to their absolute limits. Black holes form from the collapse of massive stars at the end of their lives. When their nuclear fuel runs out, the immense gravitational force of the star overcomes its internal pressure, causing the core to collapse into a point of infinite density, called a singularity, and surrounded by a boundary known as the event horizon, which is a point from which nothing, not even light, can escape. But our story doesn't end with single black holes. In the vast universe, many black holes don't exist in isolation. They often find partners, forming binary black hole systems. Imagine this: two black holes, which might have vastly different masses, orbiting around a common center of mass, like a pair of dancers performing in the dark void of space. This dance can last for billions of years, but over time, they gradually move closer and closer. What drives them closer? Part of it is dynamical friction, caused by the black holes moving through clusters of stars and gas in the galaxy. This friction slowly saps the orbital energy from the black holes, causing them to spiral inward slowly. But when they get close enough, an even more astonishing phenomenon comes into play: the emission of gravitational waves. Albert Einstein predicted in his theory of general relativity that massive objects accelerating would create ripples in the fabric of space-time, much like throwing a stone into a pond. These ripples are gravitational waves, and the orbit of binary black holes is one of the most powerful sources of gravitational waves in the universe. The emission of these gravitational waves carries energy away from the system, causing the two black holes to gradually lose orbital energy and move closer and closer until they reach a point called the final stage, where the merger is imminent. Why don't they merge easily? It sounds like everything should proceed smoothly, doesn't it? Black holes orbit closer, emit gravitational waves, and eventually merge. But in reality, physicists have faced a puzzle known as the final parsec problem. Imagine two black holes with immense masses, perhaps millions or billions of times heavier than our Sun, spiraling towards each other in the center of a galaxy. The dynamical friction mentioned earlier helps bring them closer for a certain distance. But when they get to about 1 parsec, which is approximately 3.26 light-years, or about 31 trillion kilometers, at this distance, the region around the black holes is swept clean, with almost no stars or gas remaining, rendering dynamical friction ineffective. The two black holes should then continue to orbit each other indefinitely, with nothing left to drain their orbital energy. It's like the Earth orbiting the Sun. We don't fall into the Sun because we have constant angular momentum. Similarly, with binary black holes, they should be stuck in this final orbit forever. So why do we detect mergers of supermassive black holes? This is a question that has puzzled scientists for decades. One intriguing idea that is being intensely studied is the role of dark matter. Dark matter is a mysterious, invisible substance that doesn't interact with light, but has immense gravitational influence and accounts for about 85% of all matter in the universe. Some physicists propose that certain types of dark matter, especially self-interacting dark matter, might be the key to solving this final parsec problem. Imagine these dark matter particles are not just inert particles moving in isolation, but they can collide with each other, like billiard balls. These collisions create friction within the dark matter cloud, making it behave like a viscous fluid. When binary black holes orbit through this viscous dark matter cloud, the dark matter acts like a brake, slowly draining angular momentum from the black holes, causing them to lose energy and move closer and closer until they can enter the phase where gravitational waves fully take over, leading to their eventual merger. There are also ideas about fuzzy dark matter, which are very low-mass particles that can clump together into large waves. These waves can also act to drain energy from binary black holes. But there are other ideas too, such as many stars orbiting through the binary black holes and draining energy, or even the presence of a third black hole interacting with the binary black holes and accelerating the merger process. Whatever the mechanism, the detection of gravitational waves from merging supermassive black holes has confirmed that this final parsec problem can be solved in the real universe, and perhaps by mechanisms more complex than we ever imagined. When event horizons converge, once the two black holes overcome the final parsec problem, they enter the final phase of their cosmic dance. As they spiral closer and closer, their event horizons begin to distort and stretch, eventually touching and then merging into a single, larger event horizon. This is the moment of the merger, a cataclysmic event that releases an enormous burst of gravitational waves, more powerful than the light from all the stars in the universe combined. The newly formed black hole is more massive and spins faster than its predecessors. It settles into a new, stable configuration, but the ripples it sent through space-time continue to travel across the cosmos, carrying information about this incredible event. What does this mean for our understanding of the universe? The study of black hole mergers has opened up a new window into the universe, allowing us to observe phenomena that were once purely theoretical. It provides direct evidence for Einstein's theory of general relativity in extreme gravitational environments and helps us understand the evolution of galaxies and the growth of supermassive black holes at their centers. It also offers clues about the nature of dark matter and other mysterious components of the universe. The solutions to the final parsec problem, whether it's self-interacting dark matter, fuzzy dark matter, or other mechanisms, could revolutionize our understanding of fundamental physics. Beyond the scientific implications, the merging of black holes also invites us to ponder deeper questions about the nature of reality, time, and existence. Imagine this. Each black hole has a singularity at its heart, a point of infinite density and gravity. When two black holes merge, it's the convergence of two infinities, becoming an even greater infinity. This is the most perfect unification, where two entities with immense destructive power become one, leaving no trace of their individuality. In one sense, black holes are a symbol of destruction. They devour everything. But in another sense, they are a symbol of creation, merging to form something new and greater. And the role of dark matter, invisible, intangible, yet a crucial medium that allows these cosmic giants to merge. It reflects that, Sometimes the most important things might be hidden behind the scenes, things we don't yet fully understand. The merger of black holes also makes us think about time. For an external observer, objects falling into a black hole appear to be frozen at the event horizon, never truly crossing over. This is the concept of frozen stars, which makes us question whether time is absolute or merely a concept dependent on the observer. Ultimately, studying black holes and their mergers is not just a pursuit of scientific knowledge, but a journey to understand our place in the universe, our relationship with infinity, and the meaning of existence. Black holes might just be the end of a star, but their story is the beginning of endless questions. The universe forever. If all black holes disappeared, what would actually happen? Throughout human history, we've often looked at black holes as something terrifying, cosmic monsters that devour everything in their path. But in reality, black holes aren't just space vacuum cleaners, as we once thought. They are one of the most important and mysterious components of the universe, playing a vital role in sustaining and shaping the very galaxies we call home. A black hole is a region in space where gravity is so intense that nothing, not even light, can escape. They're born from the collapse of massive stars or from the accumulation of vast amounts of matter at the center of a galaxy, becoming supermassive black holes, like Sagittarius A star at the heart of our Milky Way, which is 4 million times more massive than our Sun. Even though the mass of a supermassive black hole is only a tiny fraction, about 0.1% of the total galaxy, it has a profound influence on its dynamics and evolution. From the arrangement of stars to the birth of new ones, and even the shape of the galaxy itself. So, what if these powerful entities suddenly vanished, without a trace? What would happen to us and this vast universe? We're going to explore the potential consequences in the short term, medium term, and long term, which could lead to an end of the universe we never expected. The first thing we'd notice immediately, if all black holes were gone, would be orbital chaos, especially for the stars orbiting close to supermassive black holes. At the center of our Milky Way, there are many stars, like S2, that orbit Sagittarius A star at incredible speeds, sometimes reaching several percent of the speed of light. The massive gravity of Sagittarius A star is what keeps them anchored. If Sagittarius A star disappeared, S2 and other nearby stars would no longer be held back. They would break free from their orbits, like a stone released from a spinning sling. These stars would hurtle into space at high velocities, becoming hypervelocity stars, traveling out of the galaxy and into the intergalactic void. It would be a spectacular sight, but it's the first sign of total chaos. Additionally, the sudden disappearance of such massive objects could create gravitational waves, more powerful than anything we've ever known. These waves would ripple through the universe, warping the fabric of space-time. While the direct impact on Earth might be minimal, it would be a phenomenon signaling a massive shift in the fundamental structure of the cosmos. Another major short-term effect would be the extinguishing of light from some of the brightest objects in the universe. Quasars and active galactic nuclei. Quasars are the rapidly growing centers of galaxies, where supermassive black holes devour massive amounts of matter, releasing energy in the form of light, X-rays, and radio waves, making them shine brighter than an entire galaxy combined. If these black holes vanished, These brilliant light sources would go dark instantly, plunging parts of the universe that were once bright into total darkness. This change happens in a heartbeat, but the consequences are far more profound than we can imagine. Once the initial turbulence passes, the medium-term effects would begin to surface, severely impacting the evolution of galaxies. One of the key roles of supermassive black holes is acting as a control valve for star formation, what scientists call black hole feedback. Black holes release massive amounts of energy in the form of high-speed gas winds and radiation, which blow away the hot gas surrounding the galactic center. This prevents the gas from cooling down and clumping together to form new stars. This process is known as quenching, and it helps regulate the rate of star birth, ensuring the galaxy has enough gas to continue creating stars for a much longer time. Without black holes, this control mechanism would vanish. The gas in the galaxy would cool rapidly and trigger a massive burst of star formation in a very short time, a phenomenon called a star formation burst. The galaxy would shine brighter than ever, filled with millions of newborn stars. But this glory would be short-lived, because the gas fuel for star creation would be used up far too quickly, leaving behind a dead galaxy, with no gas left to create new stars. This would change the galaxy's evolution forever. Furthermore, the structure of the galaxy would be heavily affected. The supermassive black hole at the center plays a vital role in anchoring and maintaining the shape of the bulge, the dense central region of stars. Without that massive gravity, the bulge would start to puff up, losing its density. The shape of the galaxy would begin to warp, and it might eventually lose its beautiful spiral structure. The galaxy would become a disorganized and scattered object, and even more importantly is the impact on dark matter, the mysterious invisible substance that makes up 27% of the universe's mass and energy and holds galaxies together. Some scientists believe that primordial black holes, tiny black holes formed in the early universe, might be a component of dark matter. If this hypothesis is true, and these primordial black holes vanished, the universe would suffer a massive loss of matter. The gravity holding galaxies together would weaken significantly. Galaxies might simply drift apart, and stars would float aimlessly through space, leaving behind a void and a structureless universe. The effects we see in the short and medium term would lead to even deeper changes in the long run, ultimately determining the final fate of the universe. The disappearance of black holes would affect galaxy mergers, a crucial process in how galaxies grow and evolve. Normally, when two galaxies move toward each other, the supermassive black holes at their centers pull them together and help them merge, acting as a driving force for galactic union. Without black holes, the dynamics of these mergers would change. Galaxies might collide much more violently or fail to merge completely, resulting in strange and unstable structures. The universe we see today, filled with large, well-structured galaxies, might never have existed. Additionally, the disappearance of black holes might affect the expansion rate of the universe. Even though black holes don't account for much of the total mass, the sudden loss of such significant mass could decrease the overall gravity of the universe. This might cause the universe to expand even faster, leading to a scenario known as the Big Rip, a theory where everything from galaxies to stars and even atoms is eventually torn apart by the violent expansion of space. We might be familiar with the idea that black holes evaporate naturally through Hawking radiation, a theory proposed by Stephen Hawking, suggesting that black holes slowly release particles and lose mass until they eventually disappear. But this process takes much longer than the current age of the universe. A black hole the size of our Sun could take 10 to the power of 67 years to evaporate completely. The sudden disappearance we're imagining is nothing like this natural process, and it would bring about a catastrophe that is far faster and far more violent. From everything we've explored, it's clear that the disappearance of black holes isn't just the loss of some space objects. It would destroy the delicate balance of the universe. Black holes, which symbolize darkness and void, actually play a vital role in creating and sustaining what we call life and the beauty of the cosmos. They are the organizers that give galaxies their structure, help regulate star birth, and might even be a key part of the dark matter that holds everything together. Without black holes, the universe could become a place of chaos, structureless, and eventually empty. This brings us to a deep philosophical thought that sometimes emptiness doesn't mean non-existence, but is an indispensable part of completeness. Just as the darkness allows us to see the starlight, black holes, representing that darkness, are the creators of the conditions that allow light, stars, and galaxies to exist and evolve. We might have once feared black holes, seeing them as a threat. But after exploring the impact of their disappearance, we might actually have to be thankful they're here, because they are part of the grand balance of the universe, teaching us that even what seems like nothing might actually be everything that sustains our existence and makes the universe such a wonderful place, filled with infinite mystery. Have you ever wondered, if we were to tear open the canvas of the universe, what would be hidden behind it? In this very second, as you're listening to my voice, deep within the vast expanse of space, there's a place where time stands still, where your self would be erased, and where every law of physics humanity has discovered over millennia becomes nothing more than worthless scraps of paper. We call it a black hole. But what you see in NASA's photos, that's just the outer shell. The most chilling truth isn't that it swallows light, but what something awaits you at its very heart, a point where mathematics declares infinity, a point where emptiness holds immense density, and a point that might be the end of everything, or perhaps the beginning of a new universe. Today, I'll take you on a journey through a place no one has ever returned from. We'll dive deep into its essence to find out what truly lies there. Prepare yourself because this answer might change the way you see yourself forever. Before we dive in, we need to understand what this monster truly is. A black hole isn't a hole in space like we see in cartoons, but rather an object with immense mass compressed into an incredibly tiny size. Imagine taking the entire Earth and squeezing it down to the size of a marble in your hand. That's the density of a black hole. Its gravitational pull is so intense that even light, the fastest thing in the universe, cannot escape. Around a black hole, there's a boundary called the event horizon. It's the point of no return. Imagine you're paddling a boat in a river heading towards a towering waterfall. The closer you get to the edge, the faster the water flows. As long as you're above the critical point, you can still paddle back. But once the bow of your boat crosses the edge by just a millimeter, it's all over. For an outsider watching you fall, they would see a very strange sight. Because gravity distorts time, your friend would see you slowly moving slower and slower until it seems like you're frozen at the event horizon forever. Your body would gradually turn darker red due to the phenomenon of gravitational redshift and eventually fade into darkness. But for you, as you're falling, everything feels normal. You don't feel time slowing down at all. You just see the sky behind you gradually shrinking into a bright circle, while the darkness ahead expands to fill your vision. And once you cross that boundary, space and time swap roles. In the outside world, you're free to move forward or backward, but you can't stop time. But inside a black hole, you see time as a path, and you're forced to move only towards the center. You have no other choice. Every path of your future leads directly to that mysterious center. The deeper you plunge, gravity will begin to tear you apart. This is what physicists call spaghettification. Think about it. If you were to fall feet first, the gravitational pull on your feet would be immensely stronger than on your head. Because a mere few feet between your feet and head in a gravitational field of this magnitude represents an enormous difference. Your feet would accelerate faster than your head. Your body would begin to stretch and stretch like a strand of pasta being pulled. Bones would separate, muscles would tear, until finally your body would disintegrate into a long stream of atoms. But the horror doesn't stop there. As you're stretched, gravity will also squeeze you from the sides. You'll be stretched long and squeezed narrow at the same time. This is the fate of everything that falls in, whether it's a rock, a spaceship, or even an entire star. Everything will be transformed into fundamental information. But the interesting question is, where do those atoms go next? According to Einstein's theory of general relativity, the ultimate destination is a singularity. It's a point where immense mass is compressed to zero size. Let's pause here for a moment. Zero size, but with infinite density. In mathematics, when you encounter the word infinity, it means your equations have broken down. The universe is telling us, I don't know how to explain this anymore. The singularity is the point where all the laws of physics we've ever known collapse. It is complete darkness. But new generation scientists are beginning to question, what if Einstein didn't tell us everything? In the 1970s, the late physicist Stephen Hawking dropped a bombshell on the scientific community. He discovered that black holes aren't as black as we thought, but they can evaporate through a phenomenon called Hawking radiation. A black hole will slowly release particles bit by bit until eventually it completely disappears from the universe. And this is a huge problem. If a black hole disappears, what about the information of everything it consumed? Suppose you throw a notebook containing your secrets into a black hole. When the black hole evaporates, will those secrets be gone forever? The laws of quantum physics state that information is never lost. Information is the most fundamental thing in the universe. If information is lost, the laws of cause and effect would immediately collapse. This is the black hole information war that lasted for over 30 years. One side said the information was definitely lost. The other side said it was impossible, leading to an incredible concept called the holographic principle. Physicists like Leonard Susskind proposed that information doesn't actually fall into the center of a black hole, but it's stored on the surface of the event horizon in a 2D form. Just like the holographic sticker on your credit card. It appears to have depth and dimension, but in reality, it's a flat surface storing all the information. If this is true, What lies at the heart of a black hole might be, and even more chilling. There's a theory that the universe we currently inhabit might just be a projection from the edge of a giant black hole in a higher dimension. We might just be shadows of information stored somewhere. But if you don't believe in holograms, let's look at a more tangible theory. That is the theory of Planck stars. Some physicists believe that nature abhors the word infinity. Therefore, a singularity with infinite density is unlikely to truly exist. They propose that when mass is compressed to the smallest level the universe allows, or what's called the Planck length, space and time will experience immense resistance. Instead of collapsing to zero, it will bounce back like a ball hitting the ground. But this isn't an ordinary bounce, because immense gravity slows down time to an almost standstill. The bounce that should happen in a fraction of a second, for outsiders like us, it might take trillions of years. So, what lies at the heart of a black hole might be a star that is slowly exploding. And when it successfully explodes, it will become what's called a white hole. A white hole is the opposite of a black hole. If a black hole sucks everything in, a white hole spews everything out. Perhaps the Big Bang that created our universe might just be the explosion of a white hole from another universe. This is an endless cycle. A black hole is the end of one reality to become the beginning of another. Ultimately, what is at the center of a black hole? The true answer might still be waiting for someone to discover in the future. But one thing we can learn from black holes is about limits. A black hole is a mirror reflecting how skilled humanity is at trying to understand something beyond our grasp. We are just tiny beings on a pale blue dot, yet we can calculate what happens in a place where even light cannot reach. A black hole teaches us that. Darkness doesn't mean emptiness, but it's a place where our knowledge has not yet reached. It reminds us that even what seems to be the darkest end, like the heart of a black hole, always holds the possibility of rebirth. Perhaps each of us might have a black hole within us, a place where we harbor secrets, pain, or things others cannot see. But remember, information in a black hole never disappears. It merely transforms. Your vulnerabilities, your mistakes, all of it is permanently recorded in the fabric of this universe. We are not just observers of the universe, but we are part of the information the universe is trying to understand. When you look up at the night sky tonight, don't just see the frightening darkness, but see the infinite possibilities hidden behind that black curtain. Because perhaps what lies at the heart of a black hole might be the seed of the next universe, and all of us are part of this grand cycle. Thank you for journeying through the darkness with me. Don't forget to nurture the light within you, because even in the deepest black hole, light always finds a way to persist. The biggest things in the universe that make black holes seem tiny. Have you ever gazed up at the night sky, felt the immense vastness of the universe, filled with trillions upon trillions of stars? We often think of black holes as the ultimate mystery and the most terrifying force in space, with a gravitational pull from which nothing can escape. But what if I told you that what we're about to explore today is millions of times larger than any black hole? So much so that those black holes would appear minuscule? Get ready, because this journey will take you to astonishing truths. challenging every imagination you've ever had. From tiny atoms to the largest structures ever discovered by humanity. We will unveil the secrets of the cosmos that will leave you speechless and change the way you see this world forever. Before we reach the absolute largest, let's first understand what we're already familiar with. Black holes, regions in space with immense gravity, so powerful that not even light can escape. Black holes come in various sizes, from stellar mass black holes to supermassive black holes, lurking at the heart of most galaxies, including our own Milky Way. These supermassive black holes have masses millions or even billions of times greater than our Sun. A galaxy is a massive system composed of stars, gas, dust, dark matter, and black holes, all bound together by gravity. Our Milky Way galaxy is just one of hundreds of billions of galaxies in the observable universe. Just imagine. The supermassive black hole at the center of our galaxy is called Sagittarius A, with a mass about 4 million times that of the Sun. But compared to the entire Milky Way galaxy, which has a diameter of about 100,000 light-years, this black hole is just a tiny speck. This is the beginning of our journey. From the grandeur of black holes and galaxies, we will gradually expand our perspective to discover even larger structures. Galaxies don't exist in isolation in space. They often gather together to form galaxy groups, such as our local group, which includes the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, along with over 50 dwarf galaxies. The local group has a diameter of about 10 million light-years, 100 times larger than the Milky Way. But compared to galaxy clusters, our local group is still considered small. Galaxy clusters are much larger structures, consisting of hundreds to thousands of galaxies, vast amounts of hot gas, and significant dark matter, all held together by immense gravitational forces. A prominent example is the Virgo cluster, which contains over 1,300 galaxies and has a diameter of about 15 million light-years. The hot gas between these cluster galaxies reaches temperatures of tens of millions of degrees Celsius. The merging of galaxies within these clusters involves continuous collisions, mergers, and shape changes. So, from the tiny black holes within galaxies, we have expanded to galaxy groups and galaxy clusters that are hundreds of times larger. But believe it or not, this is just the beginning. When we look beyond galaxy clusters, we find even more colossal structures. These are superclusters. A supercluster is a group of many galaxy clusters and galaxy groups, forming a vast network resembling a giant spiderweb stretching across the universe. These structures are also influenced by the expansion of the universe. The supercluster we reside in is called the Laniakea supercluster, which means immense heaven in Hawaiian. Laniakea consists of approximately 100,000 galaxies spanning over 520 million light-years. Our local group is just a small part of Laniakea. The discovery of Laniakea in 2014 showed that galaxies in this region are flowing in the same direction, like rivers flowing into an ocean, indicating they are being pulled together by the gravity of an unseen massive structure. Within Laniakea, there is a gravitational center called the Great Attractor, an area with a very high density of galaxies. Studying superclusters helps scientists understand the evolution of the universe and the formation of these large structures. But no matter how vast superclusters are, they are still not the ultimate grandeur of the universe. And now we arrive at the pinnacle of grandeur, the cosmic web, or the large-scale structure of the universe. The cosmic web is a network of galaxies, galaxy clusters, and superclusters, interconnected into a three-dimensional spider web-like structure, extending throughout the observable universe. This is the largest structure ever discovered by humanity, and it truly makes black holes seem tiny. The cosmic web consists of filaments, where galaxies are arranged, nodes, which are points where multiple filaments converge, and voids, which are vast, empty regions. All these structures arose from the aggregation of matter under the influence of gravity since the early universe after the Big Bang. The discovery of the cosmic web confirms the idea that our universe is not homogeneous, but has a complex and ordered structure. A prominent example of the cosmic web structure is the Hercules Corona Borealis Great Wall, the largest structure ever found, with a length of approximately 10 billion light-years, covering almost 1/10 of the entire observable universe. Another example is the Sloan Great Wall, which is about 1.4 billion light-years long. These walls are clear evidence that our universe is filled with incredibly massive structures. When we talk about the largest structures in the universe, we must understand the concept of the observable universe. The observable universe is the part of the entire universe, from which light from various objects has had time to reach us since the Big Bang. Although the universe is 13.8 billion years old, the radius of the observable universe is not 13.8 billion light-years, because the universe is continuously expanding, making the observable universe approximately 93 billion light-years in diameter. Within this observable universe, there are hundreds of billions to trillions of galaxies. This is the maximum extent we can see with our current technology. But it's important to remember that the observable universe is only a part of the entire universe. We don't know how big the entire universe is or what shape it has. It could be vastly larger than our observable universe, or it might even be infinite. The concept of the multiverse is another interesting possibility. The expansion of the universe is driven by a mysterious force called dark energy, which accounts for about 68% of the total energy in the universe. The observable universe is therefore the limit of our perception, like a large bubble we can see from within. But beyond that bubble, there is still so much we don't know. Throughout our journey, we have often mentioned dark matter and dark energy. Dark matter is a mysterious, invisible substance that does not interact with light, but it has a tremendous gravitational influence. Scientists believe that dark matter accounts for about 27% of the total mass in the universe and is crucial in holding galaxies and galaxy clusters together. Without dark matter, galaxies would spin too fast, causing stars to fly out of them. Dark energy, on the other hand, is a mysterious force that is accelerating the expansion of the universe, a discovery made by scientists in the late 1990s. Dark energy accounts for about 68% of the total energy in the universe. Understanding dark matter and dark energy is one of the greatest challenges in current physics and cosmology. Finding answers to these puzzles will revolutionize our understanding of the universe. Dark matter and dark energy are reminders that, despite our scientific advancements, there is still so much we don't know and don't understand. Our journey through the grandeur of the universe, from tiny black holes to the endlessly expanding cosmic web, has shown us the wonder and complexity of what we call the cosmos. But it also makes us question the meaning of our own existence. In such a vast universe, our Earth is just a tiny speck, and our lives are but a brief moment. This might make some feel insignificant, but conversely, it makes us realize the specialness of our existence. We are intelligent beings, capable of observing, understanding, and questioning the universe. Our ability to perceive these grand scales is truly astonishing. Studying the universe teaches us humility and to always be open to learning new things. It teaches us that our knowledge is still very limited, and there is still so much we don't know and don't understand. New discoveries in the universe don't diminish us, but rather broaden our worldview and make us realize the limitless potential of humanity. Perhaps the meaning of our existence is not about being the center of the universe, but about being a part of it and having the opportunity to admire its beauty and mystery. So, no matter how tiny you may feel compared to the universe, remember that you are a part of that grandeur, and you have the ability to understand and appreciate its beauty. May your journey through the universe be filled with endless curiosity and boundless inspiration. In the boundless darkness of the universe, where emptiness stretches for millions of light years, only silence envelops everything. But amidst that silence, something improbable emerged. That is life, the beating of a heart, laughter, tears, and the question that echoes in all our minds: why? Why did this seemingly emotionless universe create the miracle called us? Imagine the vastness of the universe, hundreds of billions of galaxies, each with hundreds of billions of stars, and in a tiny corner of our Milky Way galaxy, there's a blue planet, teeming with diverse forms of life, from microscopic bacteria to giant blue whales, and of course, humans like us, trying to understand everything. The complexity of life, even the smallest cell, is an amazing system, working together perfectly. Is it an incredible coincidence that happened only once in the long history of the universe? Or is the origin of life not just a coincidence, but a necessity deeply embedded in the fundamental laws of physics itself? Throughout history, humans have always sought answers to this question. Scientists, philosophers, have all proposed fascinating ideas. Some say we are merely a byproduct of a meaningless natural process, but others believe our existence is the goal the universe is striving for. In this video, we will dive into concepts that might change your perspective on life and the universe forever. We will explore cutting-edge scientific theories and profound philosophical ideas to find out why the universe created life and what our existence truly means. To understand why life can exist, we must go back to one of the most fundamental laws of the universe. That is the second law of thermodynamics. This law states that, in a closed system, entropy or disorder will always increase. Simply put, everything in the universe tends to decay, disperse, and become less ordered. Like a hot cup of coffee left out, it will cool down to room temperature. It won't heat up on its own. Or a messy room, it won't organize itself, but will get messier and messier if no one tidies it up. But then, how did life, full of order and complexity, come into being in a universe that tends towards disorder? This is the question that a young physicist named Jeremy England from MIT proposed a revolutionary idea. He didn't see life as contradicting the law of entropy, but rather, he saw life as a direct result of this very law. England's theory is called dissipation-driven adaptation, which explains that, under certain conditions, especially when an external energy source is involved, groups of atoms will tend to rearrange themselves to absorb and dissipate energy as quickly as possible. Imagine there's an abundance of energy in the system. These atoms will find a way to release that energy, and the most efficient way to do that is to create complex structures. These structures will act like machines that help energy flow through the system more effectively, and that's the beginning of life. England explains that living things, whether tiny bacteria or humans like us, are all systems adept at absorbing energy from the environment and converting it into heat or entropy. We eat, breathe, move. All our activities are accelerating the process of energy dissipation in the universe. Simply put, life is the mechanism the universe uses to accelerate the increase of entropy itself. This idea suggests that the origin of life is not a matter of lucky coincidence, but an inevitable outcome of fundamental physics, like a stone rolling down a hill. It doesn't roll down by luck, but it rolls down because of the law of gravity. Life is the same. It came into being because of the laws of thermodynamics that push matter to arrange itself in ways that can dissipate energy most effectively. So, from Jeremy England's perspective, we are not just accidental passengers on this planet, but we are part of the process that the universe uses to follow its own laws. We are the tools that help the universe breathe and release energy. It's a fascinating idea that completely changes our view of the existence of life. If Jeremy England's theory shows us that life might be an inevitable physical outcome, another equally profound idea, and one that might completely overturn our understanding of reality, comes from the great 20th century physicist John Wheeler, who worked with Albert Einstein and Niels Bohr. Wheeler proposed the concept of the participatory universe. This idea poses a very challenging question. Does the reality we see truly exist if there is no observer? Wheeler believed that the universe is not just a static backdrop for us to observe, but our very act of observation plays a crucial role in creating reality. Sounds like science fiction, doesn't it? But this idea is rooted in quantum mechanics, especially from the famous experiment like the double-slit experiment. This experiment shows that tiny particles like electrons behave like waves when not observed, but when observed, they behave like particles. It's as if the act of observation forces them to choose a state. This phenomenon led Wheeler to propose that perhaps the entire universe only truly comes into existence when there is an observer to observe it. He called this the it from bit concept, meaning that all physical things or ultimately derive their existence from information, and this information is only actualized when an observer interacts with it. In other words, our consciousness, our act of observing, is not just passively receiving information from the universe, but actively participating in shaping the universe itself. This means that, without us, without consciousness, the universe might remain in a state of undefined possibilities, a quantum foam, waiting for an observer to collapse it into concrete reality. This concept is truly mind-bending. It suggests that we are not just living in the universe, but we are also co-creators of the universe. Our existence, our consciousness, is not just a small part of the universe, but a fundamental component that brings the universe into being. It's like the universe is a giant mirror, and we are the ones looking into it. And in doing so, we are helping to define what it reflects back to us. So, when we combine Jeremy England's idea that life is an inevitable outcome of physics with John Wheeler's participatory universe, we begin to see a truly profound picture. Life is not just a random occurrence, but a necessary process that allows the universe to fulfill its own laws and to become real through observation. We are the universe's way of understanding itself, its way of experiencing its own existence. This perspective elevates our existence from mere biological accidents to an integral part of the cosmic drama. We are the universe's eyes, its ears, its mind, through which it perceives and comprehends itself. Our thoughts, our feelings, our questions are all part of the universe's grand journey of self-discovery. It's a beautiful and humbling thought that our individual lives, our struggles, our joys are all interwoven into the fabric of the cosmos. We are not separate from the universe. We are the universe, experiencing itself. It's a journey of continuous creation, where every moment of our existence is a brushstroke on the canvas of reality. So, the next time you look up at the night sky, or ponder the mysteries of existence, remember that you are not just a small, insignificant being. You are a profound phenomenon. You are the universe's answer. You are the purpose. The universe is manifesting, and your existence is the clearest evidence that the universe creates life, to know itself, to experience itself, and to evolve through us. We are the story it tells, and we are the mind the universe uses to ponder the meaning of existence. Our existence is therefore not just personal, but it is part of the grand story of the entire universe. Everything we do, everything we think, everything we create is part of the process by which the universe is awakening to its own potential. We are the ones who bring meaning to a universe that was once meaningless. We are the ones who transform coincidence into purpose. And this is what makes our existence truly valuable and amazing. We have journeyed through complex concepts, from the laws of thermodynamics to quantum mechanics, and have seen that the existence of life may not just be a coincidence, but a necessity, deeply embedded in the structure of the universe itself. Life is the mechanism the universe uses to dissipate energy. Life is the observer that brings the universe into being, and life is the one that brings meaning to all existence. What is the philosophy hidden behind these sciences? It is the realization that we are not separate from the universe, but we are an inseparable part of it. The blood flowing in our veins contains elements forged in the hearts of stars. The air we breathe is air that has been part of Earth's atmosphere for billions of years, and our consciousness may just be a whisper of the universe trying to understand itself. So, the next time you look up at the night sky or look into the eyes of someone you love, remember that you are not just a small, insignificant living thing, but you are a grand phenomenon. You are the answer the universe is searching for. You are the purpose the universe is manifesting, and your existence is the clearest evidence that the universe creates life. Have you ever stopped to think just how small we are in this vast universe? Imagine a tiny dot, so small it's invisible to the naked eye. That dot is you, it's me, it's the entire world we live on. A world we often think is so grand, with towering mountains, vast oceans, and vibrant cities. But what if we zoom out further, far, far away, through the blue atmosphere, past the bright moon in the night sky, past diverse neighboring planets, past the scorching sun that gives life, through the immense Milky Way galaxy? How would you feel? Would you still feel as grand as before? Or would you feel tiny, so tiny you're almost non-existent in this vast universe. Today, we'll embark on a journey to explore this profound question together, to discover how small humans are in the universe and what this tininess can teach us. This journey will change your perspective forever. Hello, everyone. Welcome to our incredible journey today, a journey that will take us to explore the true scale of the universe and our place as humans in this boundless expanse. Often, we live our lives on this planet, preoccupied with the small daily matters, problems that seem enormous in our eyes. But when we look up at the sky, on a dark night free from light pollution, we see millions of stars twinkling. That image reminds us of something greater than ourselves, greater than our world, and greater than any imagination we've ever had. The question, how small are humans in the universe, isn't just a scientific one, but also a philosophical question that prompts us to ponder the meaning of existence and our role in the vast tapestry of the cosmos. Throughout history, humans have constantly tried to understand their place in the universe. From the idea that Earth was the center of everything, to the discovery that we are just a small planet, orbiting an ordinary sun, in a galaxy with hundreds of billions of stars, and our galaxy is just one of hundreds of billions of galaxies in the observable universe. This shift in perspective doesn't diminish our importance, but rather opens the door to a deeper understanding of the reality we inhabit. Today, we will delve into the true scale of the universe, from what we can see with the naked eye to the largest structures we've ever discovered. We will use easy-to-understand comparisons and stunning illustrations to help you visualize the grandeur of the universe and our own smallness clearly. Get ready for a journey that will change your perspective forever. Let's begin our journey at our own home, this beautiful blue planet, the only planet we know to harbor life. Earth has a diameter of approximately 12,642 kilometers, or about 7,918 miles, which might sound enormous to us living on its surface, with its biodiversity, stunning landscapes, and complex ecosystems. But compared to the size of the universe, our Earth is just a tiny speck of dust. Imagine our Earth is the size of a marble. You could easily hold it in your hand and see its surface details. But what if we look beyond our Earth? We'll find our neighbors in the solar system, each with its own unique and fascinating characteristics. The Sun, the central star of our solar system, is 1.3 million times larger than Earth. If our Earth were a marble, the Sun would be the size of a large beach ball, and other planets in our solar system, such as Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, vary in size from tiny, scorching Mercury to the gas giant Jupiter. But all of them are still tiny compared to the Sun. The distances between these planets are also immense. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth, and several hours to reach the farthest planet, Neptune, which is an average of 4.5 billion kilometers from the Sun. This is just our solar system, which is only a small part of the Milky Way galaxy. Our Milky Way galaxy is a spiral galaxy, composed of approximately 100 billion to 400 billion stars, including our Sun. Imagine the number of these stars. Each one might have its own planetary system, and some might even have planets conducive to life, like our Earth. The Milky Way galaxy has a diameter of approximately 100,000 light-years. 1 light-year is the distance light travels in 1 year, which is about 9.46 trillion kilometers, or 5.88 trillion miles. Just imagine how far that is. If we traveled at the speed of light, it would still take us 100,000 years to travel from one end of our galaxy to the other. If our Earth were a marble and the Sun were a beach ball, our Milky Way galaxy would be larger than the entire North American continent, and our solar system is just a tiny dot, located far from the center of the galaxy. The closest galaxy to us, and the largest galaxy in our local group, is the Andromeda Galaxy, which is about 2.5 million light-years away from us. The Andromeda Galaxy is moving towards us at a speed of approximately 110 kilometers per second, or 68 miles per second. And in about 4.5 billion years, the two galaxies will collide and merge into a larger galaxy, which scientists call Milkomeda. A galactic collision might sound terrifying, but in reality, individual stars are so far apart that the chances of them directly colliding are very small. What will happen is, the two galaxies will slowly merge. Gravity will pull stars and gas together, forming a new, larger galaxy. It will be a monumental change in the history of our local universe, and perhaps the beginning of a new era for surviving planets. The Milky Way and Andromeda galaxies are just small parts of a larger structure, the observable universe, which is the part of the universe from which we can detect light or other signals. Since the Big Bang, approximately 13.8 billion years ago, the observable universe has a diameter of approximately 93 billion light-years. Imagine this number. It's too vast for the human mind to comprehend. Within this boundary, there are hundreds of billions of galaxies, each with hundreds of billions of stars, and each star might have its own planetary system. The total number of planets in the observable universe might be more than all the grains of sand on all the beaches on Earth. Scientists believe that the observable universe is just a part of a larger universe, which we call the entire universe, which might be boundless and infinite, or so vast that we cannot even imagine it. This thought makes us realize that the knowledge we have about the universe is just a drop in a vast ocean. Galaxies are not randomly distributed in the universe, but they are grouped into large structures called galaxy clusters and superclusters. These galaxy clusters are connected by the cosmic web, which consists of galaxies, gas, and dark matter, similar to a giant spider web spread throughout the universe, while the empty regions between these webs are called voids, which contain very few galaxies. These structures demonstrate the complexity and grandeur of the universe. It's not just an empty space filled with stars, but a colossal ecosystem full of movement, change, and gravitational interactions. Having seen the incredible scale of the universe, the question that follows is, what about us humans? How tiny are we in the grand scheme of the universe? We are just specks of dust, tiny, almost invisible dots. But our smallness doesn't make us meaningless. On the contrary, it makes us realize the uniqueness of our existence. We are the only known life forms capable of asking questions, searching, and understanding the universe. We possess intelligence, curiosity, and the ability to create, which makes us stand out. We can build telescopes that see galaxies billions of light-years away. We can send spacecraft to explore other planets, and we can formulate theories that explain the origin and evolution of the universe. These abilities are not ordinary, but they are miracles of life that occurred on this small blue planet. Space exploration is not just about finding answers about the universe, but also about finding answers about ourselves. It stimulates innovation, inspires, and expands the boundaries of human knowledge. The challenges of space exploration lead to new technologies that benefit our daily lives, from GPS that helps us not get lost, to stronger and lighter materials science, or even medical technologies that save lives. All these advancements are rooted in our attempt to push our limits to explore the unknown. Space programs like the Apollo program that sent humans to the moon, or the Hubble and James Webb space telescopes that reveal stunning images of the universe, are not just scientific achievements, but also symbols of human determination, courage, and unlimited potential. They show that even if we are tiny, we have the ability to do things far greater than our size. Our journey today has taken us to explore the incredible scale of the universe, from our small Earth to the distant reaches of the observable universe. We have seen how tiny we are in the grand scheme of the universe, but at the same time, we have come to realize the uniqueness of our existence. The universe is not just an empty space filled with stars, but it is a grand story of creation, evolution, and change, and we are all a part of this story. We are products of the universe, composed of elements born in the hearts of stars. We are the universe exploring and understanding itself. Our smallness does not make us meaningless, but rather makes us realize the value of life, the importance of caring for our Earth, the only home we have, and our responsibility to continue exploring and understanding the universe. The fact that we can stand on this small planet and look out into the vastness of space and ask questions about our existence, that is the true marvel. Remember that, no matter how small you feel in the vast universe, your existence has meaning, and you are a part of this great wonder. Live consciously, seek knowledge, and appreciate the beauty of the universe around you, because everything is connected. Thank you for joining us on this journey today. We hope this journey has opened new perspectives for you and made you realize the wonders of the universe and the uniqueness of our existence. See you on the next journey. And this is the story of humans, tiny in the vast universe, yet full of meaning and wonder. May we all continue to question, explore, and appreciate the beauty of this universe, because the journey of learning never ends.